Hello students, good morning. This is Sekhar from M Sigma Gokulam. Hello students, good morning. This is Sekhar from M Sigma Gokulam. Welcome to this live video session of the Indian Engineering Services preliminary examination which was conducted a few hours ago. Most of you must have given the exam. In fact, you must have felt very happy that the paper came to be very easy. In fact, it is quite an easy paper, I can say, with all my vast experience of GATE coaching and IES coaching for the last 25 years. I can say that paper came to be very easy, not easy, very easy. In fact, we have given the GATE examination also around 2 weeks ago. I had given the GATE solutions. In fact, this year both GATE examination and IAS, both prelims came to be easy. In fact, GATE paper I had given the solutions also. You can see it was a average paper, GATE paper also. That was the solutions were given. In fact, that solutions are also uploaded by the IAS Bangalore about a few days ago. For the GATE paper, and this IES paper which was conducted a few hours ago came to be very easy. In fact, I am going to discuss the solutions and key for this IES prelims examination for the mechanical engineering. Come on, let us go into the solutions and the analysis. In fact, all the subjects were covered, but unlike the GATE, here some subjects, as you expect in the IES, some subjects will be given more priority, like power plant engineering, like strength of materials, fluid mechanics, and particularly refrigeration and air conditioning, which did not find any questions in the GATE. Now we had given the good number of questions. In the same way, IC engines were not given in the GATE, but this year this IES paper had given the good number of questions. Some subjects definitely take the front seat in the IES paper, like particularly power plant, IC engines, R&AC, they dominate, even the heat transfer. In fact, in the GATE paper, the heat transfer has given the 9 marks. This year, in fact, 9 marks has come in the heat transfer in the GATE, but this year IES slightly lesser in heat transfer, but more in the power plant. But overall, the paper came to be very easy. But slightly syllabus difference is there if we just compare the GATE paper and the IES paper, prelims paper. Because of the difference in the syllabus, the type of questions, the pattern of questions, the number of questions from each subject will be different as compared to the GATE examination and this. But definitely IES prelims questions are quite easier as compared to the GATE, because there the number of numericals will be quite more. Here there are no numericals at all. Actually, very few numericals have come. Most of the questions are the just read it and theoretical based. Just read it and put the answer like that. And also it is a multiple choice questions, and given the 4 statements, tell which statements is wrong, which statements is correct. Most of the questions are like that. But that the kind of questions you will never see in the GATE. GATE really tests the depth of the each subject by giving the very thorough numericals, carrying the lot of concept, lot of understanding, lot of knack. When you are attempting a GATE problem, you should have a complete thorough knowledge of the subject, in-depth knowledge of the subject, how to analyze the problem, how to make the assumptions. That was the GATE pattern. But when you come to the IES, as you just read the question, immediately you will be knowing the answer. And some of them elimination method also you can use. For example, you are given a 4 statements in IES, and 2 statements are just by reading you can eliminate them, and automatically the answer will come to the objective, because you will be given 1 and 3 are correct, 1 and 4 are correct, 2 and 3 are correct. By eliminating one option, you can easily get the answer in IES. 150 questions were given, but number of questions are more as compared to the GATE. Number of questions in IES are quite more, 150 questions. Almost the important subjects, every important subject like strength of materials, fluid mechanics, and the power plant, each one is having around 12 to 13 questions from each of these subjects. Come on, let me discuss about the Set A paper which was conducted few years ago regarding the prelims. Consider the following statements. Viscosity of the liquids increases with increase in temperature. In fact, wrong statement. This is a wrong statement. Viscosity decreases. Viscosity of the liquids decreases, whereas for the gases, viscosity increases with temperature. Viscosity of gases with, this is also wrong statement. Just by eliminating two, we can obviously other two will be the correct answer, because each option has got two things there. Definitely like that. See, just by eliminating these two, you can think that 3 and 4 are correct. Look at the statements. In liquids, cohesive forces predominate the molecular momentum transfer. I have explained very clearly in my lectures also regarding the fluid mechanics. The viscosity in liquids is because of the molecular cohesion bonding, not the momentum transfer. It is the cohesion, the intermolecular attractive forces among the liquid molecules is the main factor which causes the viscosity in liquids. As the temperature of the liquid increases, that cohesive bonding or the intermolecular attraction will get reduced. As such, viscosity also will reduce. Viscosity is a mechanism of fluid friction. So the molecular attractive forces or the intermolecular attractive forces are causing the viscosity in liquids. But whereas in gases, what will cause the viscosity? It is a molecular momentum transfer when high velocity molecules, gas molecules collide with the low velocity gas molecules. So as the temperature of the gas increases, the molecular activity increases. As you expect, as the molecular activity increases, more number of collisions, more momentum transfer, greater viscosity. So see, look at this. In liquids, cohesive forces predominate the molecular momentum transfer. This is correct. In gases, cohesive forces are small and the molecular momentum transfer when? During collision. Actually, he didn't mention that, during molecular collisions. So that is the correct statement. During molecular collisions. 3 and 4 are correct. So answer is C. A fluid in which shear stress is more than the yield value and the shear stress is proportional to the rate of shear strain is known as. In fact, this is the question regarding the rheology. Rheology in the sense, how do the viscosity changes with the shear rate of shear strain? So that is the question regarding the shear stress versus, if you just draw the Newton's law of viscosity is given by tau is equal to mu into dou u by dou y. This is the rate of shear strain. Dou u by dou y is called as the rate of shear strain or rate of angular deformation. This tau is called as the shear stress. Supposing if you have the straight line relationship passing through the origin, we know that it is a Newtonian. It is a Newtonian fluid. Okay, air, water, gasoline, they are all the Newtonian. But there are certain fluids where unless after the initial yield stress is passed, they don't have any deformation or rate of shear strain. This is also called as the rate of shear strain. In fluids, you will have the rate of strain, whereas in solids only it is strain there. So after initial yield stress, there will be a linear relationship. There will be a linear relationship passing like this. It is called as the Bingham plastic. Is the name of the person. Bingham is the name of the person. Bingham plastic, which is also called as the ideal plastic. It is also known as the ideal plastic, Bingham plastic. Toothpaste is the example. Toothpaste is the example for the ideal plastic is the Bingham plastic. After initial yield stress, there is a linear relationship between the shear stress and the rate of shear strain. So answer is ideal plastic fluid. And if it is a linear relationship is there, it is a Newtonian. In fact, a non-Newtonian fluid may have either like this or like this. Both are non-Newtonian. But of course, it is called pseudoplastic. This is called dilatant. These two are non-Newtonian. This is a Newtonian fluid. This is an ideal plastic, also known as or Bingham plastic. Toothpaste is example. See that is more than the initial yield value and the shear stress is proportional to the rate of shear strain is known as the ideal plastic or Bingham plastic. Look at this, two horizontal plates are placed at a distance of, the space being them is filled with an oil. The gap between them is 1.25 centimeters, that is Y. This is oil, viscous oil, having a viscosity of 15 poise. We know that dynamic viscosity unit is poise, which is 1/10 of Pascal second. 1/10 of Pascal second is 1 poise. And what is the shear stress in the oil? If the upper plate is moved with a velocity of 2.5 meters per second. The upper plate is moving with a constant velocity and the bottom plate is fixed. Okay, such kind of a flow is also called as the cohesive flow. This is also known as the cohesive flow. They call one plate is fixed and upper plate is moving. So you can just write the Newton's law of viscosity, mu into dou u by dou y. Because the gap is very small, you can write this as v by y. That means it is a linear relationship. You can propose a linear relationship because the gap is small. So the u is varying with respect to the y linearly. That is why dou u by dou y will become v by y. So he has asked the shear stress, tau is equal to, what is the mu there? Mu is given as 15 poise, 15 into 1 by 10, because we have to convert into the Pascal second. 1 poise is 1/10 of the Pascal second. 15 into 1 by 10 of the mu is 15 into 1 by 10 of. It should always be given only in Pascal second or kg per meter second into v by y. What is the velocity with which it is moving? 2.5. Gap is 1.25, but if that is given in centimeters, please convert into the meters. This is the answer you will be obtaining in Newton per meter square. Answer is 300. 300 Newton per meter square. C is the answer. 300 pascals. 300 Pascal. Newton per meter square is Pascal. Look at the next question. It is a capillary. You see, in the fluid mechanics, usually in every IES paper, the first chapter fluid properties, definitely you will ask minimum 2 questions or 3 questions. He has asked so many questions in the first chapter regarding the fluid properties, viscosity, capillarities. Sometimes they may ask about the surface tension, bulk modulus or compressibility. The very first chapter of the fluid mechanics contains properties of the fluids. There definitely 2 to 3 questions comes. Even in the gate also. Even in the gate, they will ask mostly the questions on viscosity. Okay. What is the capillary rise in a glass tube when it is immersed? A glass tube is immersed in mercury. This is all mercury. When glass tube is immersed in mercury, there will be a depression. The meniscus will be like this. There will be capillary depression. H is capillary depression. Because why mercury in fact gets dipped? Because in mercury the cohesive forces are greater than the adhesive forces. If the same glass tube is kept in water, then the water would have risen in the glass tube. Because there adhesion is more than the cohesion. So the liquid may rise or may dip. In the mercury, cohesion is more dominating than the cohesion is much greater than the adhesion. Mercury don't wet any surface. Okay, for mercury, cohesion is greater than the adhesion. That's why capillary rise or capillary depression is 2 sigma cos theta divided by WR, where W is the rho g, which is the specific weight of liquid. Mercury, which is, we know that is 13.6 into 9.81 kilonewton per meter cube. This is a specific weight of liquid, that is mercury. Just sigma is the 0.52 Newton meters. This is sigma given surface tension. Theta is 130. Theta is clearly given. Even if it is not given, you should remember. Theta is 130 for the mercury and theta is equal to 0 for the water. Remember that. Theta is equal to 0 for the water and theta is equal to 130 for the mercury. That is why your cos 130 is negative. H value will be negative, which means there is a depression. H is negative means there is a depression. Okay, capillary depression, that is 2 into 0.52 into cos 130 divided by cos 130 divided by 13.6 into 9.81, that is kilonewton per meter cube. I am converting everything into the newtons, into 10 cube divided by, what is the radius? Diameter is given 2 mm, that is 1 mm radius. So this is the formula for H, capillary depression. You will get answer will be minus 0.5 centimeter. Answer is D. Minus sign only shows that it is a depression. If it is water, then H will be positive because water will rise inside the glass tube because the adhesion is more than the cohesion. there are two kinds of forces, adhesive forces and cohesive forces. Capillarity is because of the relative magnitudes of the adhesion and cohesion. Look at this. This is regarding the pressure measurement. Always one question will be there in IES and also maybe in the GATE regarding the manometry or the pressure measurement or hydrostatic forces like that. So, manometry, hydrostatic forces are very important topic where you have to give a focus. At least one question usually appears on either GATE or IES prelims. One end of the piezometer is connected. What is actually a piezometer? When a liquid is flowing, inside a pipe, piezometer is simply a glass tube, transparent glass tube, which is connected to the pipe where some liquid is flowing. The height of the liquid rising inside that glass tube will directly indicate the pressure head, the static pressure head of the flowing liquid at any particular point. You want to measure the pressure here, just connect a transparent glass tube there. The liquid will rise. Obviously, this height will indicate the pressure. One end of the connected to the point where pressure is to be measured and another end is open to the atmosphere. Correct? That statement is very much correct. But piezometer is not suitable for measuring very high pressures. When your liquid pressure is very, very high, then immediately the liquid will rise too much and it may spill over from the piezometer. So, high pressures it cannot suitable also. Okay, very high pressures, and it is not suitable for gases. If the gas pipe is connected, gas will escape. So, only moderate pressures, that too of liquids. So, a limited usage. Inverted U-tube differential manometer. Suppose that a liquid is flowing inside a pipe, you want to measure the pressure difference between two sections. Okay, an inverted U-tube manometer, this is a manometric liquid, usually of lesser specific gravity than the flowing liquid, because this is a manometric liquid. SM will be lesser than the liquid specific gravity of this flowing liquid. Usually it is used to measure the low pressures. Not, this is wrong statement. Actually, if it is low, then the answer would have been correct. This is called inverted U-tube manometer. This is the manometric liquid. And U-tube differential manometer contains generally we are supposing if you want to measure the pressure difference between two sections, a water is flowing. Usually you will use the mercury, a heavier liquid than the flowing liquid. A simple U-tube manometer, this is a simple U-tube manometer, U-tube differential manometer, which measures the pressure difference, static pressure difference between these two sections. U-tube differential manometer measures the static pressure difference between two different sections. Usually it will be mercury. If it is water, this will be mercury. Sometimes if it is air, say for example this is air, it can be water. But it should be considerably heavier than this. The specific gravity of this liquid will be much more than the specific gravity of the flowing liquid. 3 is correct. So, answer end 1 and 3. This is the correct answer. Generally, inverted U-tube manometer is used to measure the low pressure differences. Okay. So, that is inverted U-tube differential manometer. Answer is 1 and 3. This is a problem, numerical. A circular opening 3 meter in diameter in a vertical side of a tank. There is a tank. There is a circular plate of diameter 3 meter. Okay. What is the force on this disc? This is a disc. This is a disc. What is the force on the disc? If the head of the water, the free surface, the free surface of the water above the horizontal diameter, say this is a horizontal diameter. This is a horizontal diameter. No? So, this is the height is given as 5 meter. This is 5 meter. What is the hydrostatic force on this disc? Very simple question. What is the formula for the hydrostatic force, which is also called as the total pressure? Total pressure or hydrostatic thrust. Total pressure or hydrostatic thrust or hydrostatic force will be WA x bar. What is that x bar? The depth of the center of gravity or centroid of the that surface, vertical lamina you can think of below the free surface that happen to be 5 meters. What is the W of water? 9.81. Specific weight of water is 9.81 kilonewton per meter cube. What is the area there? Pi by 4 d square into 3 square into x bar is 5. Directly answer is in kilonewton. Straight question. It is a hydrostatic force on a vertical lamina, vertical plate given by WA x bar. What is it x bar? The center of gravity. This is the CG. Center of gravity or centroid also both mean the same. Center of gravity or the centroid of the lamina is at this location. Center of that circular plate, which is at a depth of 5 meters from the free surface, which is called as x bar. So answer is happening to be 346.7 kilonewtons. This is answer. Wx bar. Even for the inclined plate, it is a Wx bar. Horizontal plate or a vertical plate or inclined plate, for all the kinds of the hydrostatic forces, there is only one formula, Wax bar. Whether it is a plate is horizontal, whether the plate is vertical or whether it is inclined, the total pressure formula, hydrostatic thrust formula is Wax bar. X bar is the vertical depth of the centroid of the lamina directly below the free surface. Okay, this is the free surface. But of course, the center of pressure definitely lies below. This is the location where this total pressure acts. This is the location where the total pressure acts. This here the location which is called center of pressure. This total pressure will be lying below the center of total pressure will be acting not at the centroid, that acts at a point below the centroid. That means center of pressure, it is the location where the total pressure acts. What is the meaning of total pressure? It is a hydrostatic force that will be acting at a location below this, vertically below the centroid of the lamina. Of course, the depth can be easily calculated, x bar plus Ig by Ax bar. What is that h bar? H bar is the depth of the center of pressure where this total pressure is acting. Calculated total pressure is acting 346.7. Like this question is also direct question. So all the questions of the FM which are I have asked around 11 to 12 questions, all are direct. Very simple, very simple questions asked. This much easy questions you don't expect in GATE but sometimes they may match in the GATE also, but most of the questions of the GATE will be tougher than these IAS prelims, because there will be numericals, there will be conceptual numericals which will really test your depth of the knowledge. Okay. Petard tube is a device which is used to measure the rate of flow. Wrong. Generally petard tube when it is placed, petard tube is meant for measuring the velocity of the water coming from the upstream or any liquid. If you want to measure the velocity, then the petard tube is used. It is not for the flow rate. Orifice meter is a device used for the measuring of velocity. That is also wrong. That is also wrong, right? Because orifice meter is meant for measuring the not the velocity of flow, rather it is meant for measuring the discharge or the flow rate. Orifice meter, venturi meter, all these are meant for measuring the discharge or the volume flow rate, where the petard tube is meant for the velocity. In fact, we have the two very different varieties of the petard tube, Prandtl petard tube and the petard tube, but wherever it is meant for measuring the velocity and also to measure the stagnation pressure. It is meant, petard tube can measure the stagnation pressure and also it can measure the velocity. Venturi meter consists of a converging part, diverging part and throat. This is the throat. What for this venturi meter? To measure the discharge or the volume flow rate. So three only correct. Orifice and venturi meter is more accurate than the orifice. What is an orifice plate? Orifice plate is simply a circular plate, thin circular plate attached to the side walls of a tank. When the water is allowed to pass through that orifice plate, this is an orifice plate. In fact, there will be a vena contracta, etc. This is an orifice plate. You will take the pressure difference by applying the Bernoulli's equation. You will take the You will take the pressure difference between the upstream and downstream, where at the vena contracta, from which you will be calculating the discharge. This is orifice plate. Venturimeter. This is venturimeter. Converging portion, throat, and the diverging portion. It also measures the, but only thing is the coefficient of discharge. Here it is quite higher. Here the coefficient of discharge for the orifice plate somewhere around 0.64. Venturimeter is more accurate in measuring the discharge as compared to the orifice plate. What is the pressure gradient per meter length width for the laminar flow of a oil with a maximum velocity between two horizontal fixed plates? See, it is the flow between two fixed plates. It is not the coated flow. Coated flow means one plate is fixed and other plate is moving the top. That is a coated flow. This is the flow between two fixed plates. We know that flow inside a pipe. If the flow is laminar, say flow is liquid is flowing inside a pipe, a viscous liquid. A pipe is there. What if the flow is laminar? Say for example, assume that the flow is a laminar flow, that is the Reynolds number is less than 2300 VD rho by mu. What is the velocity distribution? We all pretty well know that it will be a parabolic with the maximum velocity at the axis and zero velocity at the pipe boundary. It is parabolic. U is a function of r. We all know that U is a function of r. What kind of function? It is parabolic. Had it been turbulent, then the function would have been a logarithmic function. Okay, we all know that this is regarding the laminar flow, which is also called as the Poiseuille flow, flow through a pipe. It is a pipe, but here it is a flow between the plates, fixed plates. Both are fixed plates. Here also incidentally it is a parabolic. Here also it is a parabolic with U maximum at the mid section. This is Y. If this gap is H, here in this direction, U is a function of Y. U is a function of Y, and in fact U will be given by U maximum. U maximum where? U maximum at the section, and U is the at any distance Y. U is equal to U maximum into 1 minus Y square by H square, where H is the distance between the plates. This is a plate, this is a fixed plate. The distance between them is H. And V average, generally which we always calculate the V average meant for measuring the discharge. What is the use of that average velocity to measure the discharge? V average will be 2/3 of the U max. In this case, U max laminar flow, it is exactly double. Mind that in here it is exactly double the V average. Here it is 2/3 of the U max is the V is the V average will be the 2/3 of the U max, and the pressure gradient delta P by L, it is a pressure gradient along the x direction. This is the x direction, will be pressure gradient along the x direction is given by U max, which is the maximum velocity which you are seeing at the y is equal to 0. That is exactly mid section. Don't call it as an axis. You can't call it because this is a midpoint, that is H by 2, we can say this is H by 2. Okay, U max into 2 mu by H square. This is the formula for the pressure gradient. Pressure gradient means what? Per unit distance in the direction of the flow, how much pressure drop will be there? It is called as the pressure gradient. As you are going in the x direction, per unit distance, how much pressure will be decreasing, how much change in pressure will be seeing. We all know that whenever a liquid is flowing inside a pipe or inside a duct, in between the plates, the pressure keeps on decreasing owing to the frictional resistance. Owing to the frictional resistance, or maybe owing to the viscosity of the fluid, the pressure keeps on decreasing in the direction of the flow. What do you mean by pressure gradient? per a unit increment in distance of x, how much drop in pressure will be there, how much decrease in pressure is there, it is called as the pressure gradient per unit increment. It can also be called as a dp by dx. Of course, it is a minus there. Why minus? Pressure keeps on decreasing in the positive, in the direction of the flow. This is the direction of the flow, right? So we just substitute there, U max is given as 2, U max is given as 2, that is mu value is given as dynamic viscosity is 2.5 divided by H is 0.05 whole square. It will be 4000 of negative value. Why negative? Why negative? Because as x increases, minus sign only shows that as x increases, pressure keeps decreasing. Minus only you have to keep. This is always be minus, pressure gradient. And that is a constant. Incidentally, here also the pressure gradient dp by dx is constant, but not governed by that formula. Here also you can, that is a constant, it is given by, that is by delta p by L. In fact, this Huygens-Poiseuille equation only is calculating this 32 mu VL by WD square. That is the formula for calculating the pressure drop per unit length. Head loss due to friction, no, which we use it as the Huygens-Poiseuille equation for this laminar flow through the pipe. Here also the dp by dx is a constant. That means pressure decreases linearly with increase of x. The only difference between this and this is, here it is a pipe flow, that is a flow between parallel plates. The velocity distribution is different there and different. Both are parabolic. Here also parabolic. Here also the maximum velocity at the mid plane, at the mid section, at the mid, exactly at the mid location between the two plates. Here also the maximum velocity at the axis. Incidentally, here the maximum velocity will be twice the average velocity. What is the use of average velocity? To calculate the flow rate. To calculate the flow rate, average velocity into area of flow. Area of flow, in case of the pipe, it is pi by 4 d square. Here it will be the, what is the area of flow? This height into per unit width perpendicular to the plane of the figure you may consider. That is the area of flow. Area of flow and this velocity must be perpendicular. That is called discharge formula. Whenever you are calculating the discharge, we always be using the average velocity. Why we need to define the average velocity? Because u is a function of r here. See, u is a function of r. Here u is a function of y. Okay, in this case, where y is the distance measured from the exactly midline, where that is, this is at a distance of h by 2 from the plates. So answer is minus 4000. Both are similar. Only difference is here the u maximum formula is 2 twice the average. Here the average velocity is 2 by 3 of u max. Here the average velocity is half of the u max. That is the only thing. Right. Now this question is regarding the kinetic energy correction factor and the momentum correction factor. This question is regarding the kinetic energy correction factor and momentum correction factor. First of all, we should know what is kinetic energy, what is the momentum. Whenever we are talking about the flow through a pipe, you see a velocity distribution. You see a velocity variation with respect to the radial coordinate. This is the r, radial coordinate. U is a function of r. We know that both in laminar flow and is in the turbulent flow, both in the laminar flow and turbulent flow, u is a function of r. Fine. What is the, on an average basis, because for the entire cross section, if you define the average velocity, if V is the average velocity is there, discharge is given by V average velocity discharge, this is into area of flow, that is a pi by 4 d square, pi r square otherwise, area of flow. What is the mass flow rate? Density, density into average velocity into area of flow, that is pi by 4 d square. Kinetic energy flowing through a section, passing through a section is half m dot into v square. Is not kinetic energy passing through a section, that becomes half rho half rho V average square, half V average square into area of flow. So this is the kinetic energy passing through a cross section based upon the average values. Why we need to define the average values? Because U is a function of R, right? Then why there is a correction factor required? Because if you just take the, so for example, if you just take the a differential elemental ring of flow, say for example at some differential area where the velocity is given by U, right? This is a U. So for that differential area, what is the differential mass flow rate? Rho differential area into U. This is the differential mass flow rate. What is the differential kinetic energy? Differential kinetic energy passing through that elemental differential ring will be half dm dot into U square, half m square. No? Dm dot is the mass flow rate passing through that. It is the differential mass flow rate. Differential mass flow rate passing through that elemental ring like this. Okay, half into rho into dA into U square. U into U square, it becomes U cube. So this is the differential kinetic energy. But for the entire cross section, if you want to do that, therefore for the entire cross section, kinetic energy per second will be integral half rho U cube dA. This is based upon the actual. This is based upon the average. So definitely the kinetic energy correction factor will be what is based upon the, see that, ratio of the kinetic energy per second based on the actual velocity to the average velocity. This is calculated based on the average velocity. This is calculated based upon the actual velocity. This is the actual one. So the ratio alpha, kinetic energy correction factor will be half integral rho U cube dA divided by half rho A V average. Look at this, look at V average rho m like that, half m dot, no, half rho A V, sorry, this will become, this is the cube, this will become the cube there. Actually by mistake I written the square, it should be the cube. See the half m dot contains what? What is m dot? Rho A V into V square. This is also average based on the, that will become V square into V average. That becomes rho V cube into area of flow. Area of flow is, we know that. What is the area of flow? Pi r square, where r is the radius, that. So that is based on the average. This is based on the actual of rho A V cube. So this is the kinetic energy factor. This alpha is equal to 2 for the laminar flow, because velocity distribution is clearly parabolic. If it is 1.1 for the turbulent flow, because in the turbulent flow velocity variation, the turbulent flow velocity distribution is not parabolic, it is more of a flatter at the core, more of flatter, uniform, more or less uniform, appears more or less uniform, unlike the laminar flow where you may see the parabolic. If it is a turbulent flow, it is a logarithmic velocity distribution. So that is why its value, alpha value is lesser. Alpha is called as kinetic energy correction factor. In the same way, momentum correction. What is the meaning of the momentum correction factor? You see, for example, if you take the velocity distribution, I'm just talking about the momentum correction factor. All these velocities were averaged for the entire cross section. We define some average velocity. Momentum, what is the definition of the momentum? Mass into velocity. What is the rate of momentum? Rate of momentum will be momentum flowing through a section per second. That will be mass flow rate into velocity. What is the mass flow rate on the average basis? Rho A V average into velocity, that becomes V square. This is on the rate of momentum based upon the average values, based on average value. But actual values, if we just take in the similar lines, if we just take a differential elemental ring, if we just take the differential elemental ring of flow where u is the velocity, what is the differential mass flow rate? Rho dA is the differential area, that is the differential area, this one, into u. That is, what is the rate of momentum passing through that? Rate of momentum passing through that differential elemental ring, dm dot mass flow rate into velocity, that is rho dA into u square. Okay, this is the rate of momentum passing through elemental ring, and if you integrate it, you will get the based for the entire cross section. If you integrate, then that will divided by this one. This is the based on the average. That is called as the momentum correction factor beta. That is based on the momentum correction. See, so first question on this answer is first option is correct. Kinetic energy based on the average velocity to know. This is momentum correction factor is defined as the ratio of the momentum of the flow per second based on the actual velocity to the momentum of the flow per second based on the average velocity. 1 and 3 are correct. Look at this. This is the, if you integrate it, if you integrate this, what is the total momentum passing through a cross section per second? Integral rho u square dA. This divided by this one. This divided by integrating, this is the total momentum passing through a cross section based on the actual velocity. This is the total momentum passing through a cross section based on the average velocity. That divided by this one is called as the momentum correction factor beta. If the kinetic energy correction factor is alpha, this is the momentum correction factor beta. So answer is based on the definition. Look at the momentum correction factor is the ratio of the momentum of the flow per second based on the actual velocity to the based on the average velocity. What is rate of momentum? That is momentum passing through a cross section per second. Mass times velocity is the momentum divided by time. That is mass flow rate into velocity is the momentum passing through a cross section. If you calculate it based on the average velocity, that is the denominator. Numerator will be the actual one. So based on the actual velocity divided by based on the average velocity is called as the momentum correction factor. 1 and 3 are correct. This is the answer. Look at this. An oil is flowing. Flowing through a pipe of diameter with a velocity. What is the head loss due to maintain for a length of 1000 meters? See, for any flow, for turbulent, for laminar as well as turbulent, flow, for laminar as well as turbulent flow, head loss due to friction is given by only one formula, FLV square by 2GD. This is known as Darcy-Weisbach equation. This is known as Darcy-Weisbach equation meant for calculating the head loss due to friction. This is the head loss due to friction. Both for laminar flow and turbulent flow you can use, where F is called Darcy's friction factor. But here you have used a different wording, coefficient of friction. If this is exactly 4 times coefficient of friction. This F is different. This is that. So therefore, head loss due to friction will be 4 FLV square by 2GD. This is not Darcy's friction factor. It is the coefficient of friction. This F is different, that as this F is different. This is the coefficient of friction. You substitute all the values, you will get the length is given, length is 1000 meters, diameter is given, that is 0.3 meters, velocity is given, velocity is also given. With a velocity is 5 meters per second, everything is given, G is 9.81, take it, F is the coefficient of friction, this is, when you write 4FL V square by 2GD, this F is the coefficient of friction. When you write FL V square by 2GD, this F is called as the Darcy's friction factor. Mind that point, answer will be 84.9. Darcy's friction factor is 4 times the coefficient of friction. But most of the occasions, we always use the Darcy's friction factor only. Majority of the problems either given in the GATE or IES, 90%, 99% cases we will be using FL V square by 2GD, where F is called as the Darcy's friction factor. That equation is valid for both the laminar flow and the turbulent flow, and this Darcy's friction factor only is equal to the 64 by Re for the laminar flow. In laminar flow, friction factor depends only on the Reynolds number. This is the Darcy's friction factor. Coefficient of friction is here, 4FL V square by 2GD. I repeat once again, if you write the 4FL V square by 2GD, this F is the coefficient of friction. If you write the FL V square by 2GD, F is the Darcy's friction factor. The apparent viscosity of a pseudoplastic fluid decreases with the decrease in shear rate. Again, he had asked the question regarding the rheology. This subject is only called as rheology, means how the viscosity of the fluid changes with the rate of shear strain. Rate of shear strain. As we know, this is a Newtonian fluid, this is a pseudoplastic, this is a dilatant, this is the elastic solid, this is an ideal fluid, this is an elastic solid, this is ideal fluid, x-axis is ideal fluid, y-axis is the elastic solid, this is the pseudoplastic. This is the dilatant. See that slope of this non-Newtonian fluid, that shear stress versus, this is called as this slope is called as apparent viscosity. See, for that pseudoplastic, that apparent slope of that shear stress versus rate of shear strain, that slope keeps on decreasing. For the dilatant fluid, if you just look at the slope, that slope is increasing. Therefore, the apparent viscosity of it decreases with a decrease in apparent viscosity. The apparent viscosity of a pseudoplastic fluid. The apparent viscosity of it decreases with the decrease in shear rate. Apparent viscosity, it increases with increase in the shear rate. Apparent viscosity, look at this, it is increasing here. Here this slope is increasing. That statement 2 is correct. Bingham plastic fluid requires a finite yield stress. This is a Bingham plastic. Toothpaste is example. So this is the initial yield stress we have to pass. Initially, you have to overcome the initial yield stress to have that linear relationship between the shear stress and the rate of shear strain. This is a Bingham plastic or ideal plastic. So this is correct. 2 and 3 are correct. 1 is wrong, because apparent viscosity of it is decreasing. It is decreasing, no doubt it is decreasing, but with the increase of shear rate. As this is increasing, the slope keeps decreasing, but he has given the answer, this is given in the decrease. So that is why this is a wrong statement. If he has given the increase, then first statement also would have been correct. This is pseudoplastic, this is the dilatant. Toothpaste is example for Bingham plastic, and for the pseudoplastic is a starch solution. And for the dilatant fluid, it may be paints. Example, you can take it as paint. For the pseudoplastic, it is the starch solution we can take. So all this subject is called as the rheology. So the variation, how the viscosity changes with the rate of shear strain, this is only called as rate of angular deformation or rate of shear strain, dou u by dou y. This is the shear stress. This is a Newtonian. Both pseudoplastic and dilatant are non-Newtonian. If the straight line you are getting passing through the origin, it is a Newtonian. Example is water and air. This is a Newtonian fluid. It's even the gasoline also. Pseudoplastic example is a starch solution. Dilatant you can take it as the paints. Bingham plastic is toothpaste. So these are the things you have to keep remembering. And for the pseudoplastic, the apparent viscosity keeps decreasing with increase of rate of shear strain. So look at the tangent there. The slope of the tangent keeps decreasing. Here the slope of the tangent keeps increasing for the dilatant fluid. The dimensional formula of the bulk modulus of elasticity K. What is the bulk modulus of elasticity? Volumetric stress divided by volumetric strain. That is the bulk modulus of elasticity, which you see in the strength of materials also. But this is also defined for the fluids. The reciprocal of the bulk modulus only, it is called as compressibility of fluid. Compressibility of fluid is the reciprocal of the bulk modulus of elasticity. Strain doesn't have the dimensions. Therefore, stress, Young's modulus, bulk modulus, shear modulus, all will have the pressure, including pressure. All have same dimensions. All have same dimensions. Pressure, all the moduli of elasticity, pressure, stress, everything will have the same units. Newton per meter square. That is, Newton is ml t power minus 2 divided by L square. It becomes ml minus 1 t minus 2. Answer is D. Simple question, very simple question. In fact, in this year GATE also, see, whenever you are learning a physical quantity, one should be very, very thorough with the units and dimensions. Look at the GATE question asked in this year, about 2 weeks ago, GATE exam there. He has asked a question regarding the Rayleigh theorem. He has given the surface tension, dynamic viscosity, everything, unless and otherwise you know the dimensions, we cannot answer that question. There was a question, look at that, fluid mechanics. By the by, that response sheet was released. The actual paper also of the GATE, this year GATE 2024, you can see there. There was a question on the dimensional analysis, where in the dimensional analysis, when you are using the Buckingham pi theorem or the Rayleigh theorem, you must have the complete idea of all the physical quantities dimensions there, like this. Right, all the questions about, there are about 12 questions asked in the FM, but all are easy. All are very, very simple, except that one or two definitions of kinetic energy, correction factor and momentum. They are also, if you know the people who prepare well for the incompressible flow through pipes, questions on incompressible flow through pipes are very, very common in both GATE and IES. See, for example, this year GATE, he has asked the flow, incompressible flow through pipe, but pipe networks. Pipe networks he has asked, like this. Is a pipe network, flow is happening simultaneously between this. This is a flow is coming here, it is happening. This is a pipe networks formula. This is a pipe networks formula question. Okay. Flow is coming like this, it is from this joint, it is getting diverged like this. So this pipe, it is a pipes in parallel. In this example, pipes in parallel. The flow is coming like this, it is going like this. Pipes are in parallel. What is the concept? The sum of all the discharges Q will be Q1 plus Q2 plus Q3. That is the GATE question. This is the GATE 24. And another clue is Q is equal to Q1 plus Q2 plus Q3, that is 1. Another thing is H head loss due to friction is same. H of 1 is equal to H of 2 is equal to H of 3. So that is the pipe 1, pipe 2, pipe 3, if you think. This and this are same thing, pipes in parallel. Head loss due to friction is same. Total discharge is the sum of the individual discharges. This is called pipes in parallel. There is another kind of a network also, pipes in series, where the discharge is same in all the pipes, but the total head loss is the sum of the individual head losses. So this kind of a incompressible flow through pipes is the most important chapter in the fluid mechanics, in the gate and also in the ES. One should have a very clear idea, my major losses, minor losses, Huygens-Poiseuille equation, velocity distributions, Darcy-Weisbach equation, pressure losses, and what is the shear stress distribution, what is the velocity distribution. All these areas are very, very important in the gate point of view also. Look at this question. This is a questions on the strength of materials there. Tensile stress is positive and compressive. Generally in the stress analysis, what is the convention you follow? Tensile stress is positive and compressive stress is negative. Yes, particularly when you are drawing the Mohr circle, particularly biaxial stresses, sigma 1, particularly biaxial stresses, if you take like this sigma 2, then this one we treated as tensile, this is positive, then this compressive stresses you are treated as a negative. Generally that is a tendency. First one, that is a convention, sign convention we can say, convention we follow regarding the stress analysis. A pair of shear stresses in parallel planes forming a clockwise couple is positive and anti-clockwise is, this is also correct. And clockwise angle is taken as a negative and counterclockwise taken as the positive. In fact, this is also seems to be correct, particularly when you want to draw the Mohr circle, supposing if you are given a plane like this, some angle. So we are going the anti-clockwise, that theta is taken as the positive. All the three are correct. Generally, sign convention goes like that, particularly whenever you are drawing the Mohr circle or while calculating the principal stresses and principal strains. This is the usual sign convention we follow. This is tensile is positive, compressive is a negative. On a parallel, clockwise couple is positive and anti-clockwise couple is negative. All the three are correct. D is the answer. But generally, third option is something like an ambiguity. In some textbooks, see, it all depends upon the author and textbooks there. Sometimes clockwise is taken as a positive and anti-clockwise is taken as a negative. Depends on the textbook but most of the standard textbooks what we follow for the gate or the IES preparation, these are the sign, all three are correct. Principle of superposition. This principle of superposition is very famous in applied physics. In many subjects we use, not only in the strength of materials. It is like this. Supposing an elastic member is comprising of three different parts. There is some tension here, and this loading P1 is acting here. There are internal forces, P2 is acting here, P3 or P4, this is like this, okay. And some member may be under tension, one member may be under compression, depending upon what are the net load coming onto the particular part of the member. So supposing this may be under tension, this may be under compression, again this may be under tension. So what total elongation will be the net some algebraic sum of the individual elongations or contractions. The total elongation, if you take that, total elongation is the algebraic sum of individual components, individual contractions or expansions, individual contractions or expansions. Supposing the part 2 is compression, that it will suffer the decrease in length, negative. This will suffer an increase in length, positive. This will suffer an increasing length, elongation, positive. We have to add them of contractions or expansions. See, that kind of a principle is called as the principle of superposition. States that if a body is acted upon by a number of loads on various segments, then the net effect on the body is the sum effects of the caused by each of the acting independently on the respective segment of the body. but you should give the algebraic sum. So because if it is a contraction, if it is compression force, that will get a decrease in length. Because of the tension, it will get increase in length, this segment. This segment will have increase in length because of the tension. This may have the decrement in length. That is why I said algebraic. It is a minus, negative, because deformed by decrease in length. This is a positive, this is a positive. So answer is 1 is correct. Superposition principle applies to all the parameters like strain, deflection, but actually not all. There are few exemptions may be there. Few exemptions will be there, like strain energy and all that, but generally we take it as the regular things like in this case. So individual segments would have a individual contractions or expansions or the strains. We have to add them up algebraically so that the total elongation or the total contraction could be obtained by adding the contractions or the expansions of the individual parts. The total elongation, total contraction is the algebraic sum of the individual, algebraic sum of individual of each of all components, of all segments. This is segment 1, this is segment 2, this is segment 3. If you take that, so then we have to calculate this expansion, contraction of this, expansion of this, we have to add them up algebraically. This is correct, this is correct. Is unapplicable to with non-linear, wrong. It is applicable to only for the members to follow the Hooke's law. Stress is directly proportional to the strain within the elastic limit. Okay. Answer is 1 and 2. Answer is A. It's a very simple question. People who prepare for the engineering entrance examinations also nowadays they do know this formula. When two rails are connected end to end without any gap, when there is no allowance for the expansion, what is the stress? Thermal stress. It is also called as the thermal stress due to the temperature change. Alpha into delta T into E is the Young's modulus. Alpha is the coefficient of linear expansion. He has given 11 into 10 power minus 6. Change in temperature is 80 minus 24. Young's modulus is given as 2 into 2. Giga means 10 power 9. Giga means 10 power 9. Megapascal means 10 power 6 megapascal. Answer will be 126.28. Just apply that formula. Thermal stress. In this case, is it subjected to the compressive or tensile? Because it is liable to expand. It is wanted to expand, but there will not be any chance. It wanted to expand. So that is under compressive nature. Tensile or compressive? It is a compressive. Because it is a heating, Supposing if it gets cooled, supposing if the same thing, the rail gets cooled, then there won't be any stress. Supposing this is the situation. If the rail gets cooled, then there will be a gap. There won't be any stress there. Because it is increase in temperature, initially 20 degrees, 24 degrees. Initially 24. Now the temperature is changed to 80. That means it would like to elongate, but there is no space. It would be under compressive stress. Supposing after cooling, supposing if it is 24, after cooling from 24, then the rails will be, because they suffer the decrement in length. Because any elastic member, it may have a thermal expansion properties. If the temperature is increasing, the member elongates. If the temperature is decreasing, member contracts. The coefficient of thermal expansion has been given alpha. Delta T is the change in temperature and E is Young's modulus. Supposing if the member is like this initially at 24, same member from 24 to 10 degrees Celsius cooled, then there will not be any stress in use, because this gets a decrease in length, this gets a decrease in length, there is a gap will appear, no stress at all. Thermal stress will be induced only a part of the expansion or the total expansion or total contraction is prevented from happening. A part of the expansion or the total expansion is prevented from happening. Thermal stresses are commonly asked in GATE and as well as I think GATE 24 also there is a one question on the, there is a one question on the thermal stress in gate 24 also. When a member is subjected to a pure shear, this is a pure shear, complementary shear, pure shear or the complementary shear tau, pure shear stress. Best example is torsion. A shaft subjected to a torsion is under pure shear. An element of the shaft under a twisting moment or under a torque is assumed to be under pure shear. This is a pure shear. Then if you take an angle of 45 degrees, if you just take an angle of 45 degrees, then there will be a tensile stress, there is a tensile stress on that, which is of the same magnitude. Yeah, this is tensile. And there is another plane which is making a 90 degrees, on this plane there will be a compressive stress, which is also the same magnitude. There are two planes which are at an angle of 90 degrees to each other, one at 45 and other at 135. So this is under tension, this is under tension, this plane is under compression, this plane, which is that the angle between those two planes will be 90 degrees. If a member is subjected to a pure shear, if you just take a plane at 45 degrees, there will be a plane on which there will be a tensile stress of which is equal in magnitude to this shear stress. And if you take an angle at 135, that means 45, there is a plane perpendicular to that plane 45 degrees on which there will be a compressive stress. This is a compressive stress which is also of the same magnitude. There is one plane will be there, there is another plane. On this, if this is tension, on this there will be compression. Both magnitudes are tau. Both the tensile and tensile stress and this compressive stress are of equal magnitude. So answer is A. A piece of material is subjected to a direct stress 100 MPa, here 100 MPa. Biaxial stresses are two-dimensional stresses. This is 100 MPa, this is also 100 MPa, both are tensile, same tensile stresses. If we just draw the Mohr circle, the radius of the Mohr circle becomes 0. What is the radius of the Mohr circle? Sigma 1 minus sigma 2 by 2, both are equal, radius of the Mohr circle becomes 0. So this will be radius of the Mohr circle is 0. So there is no shear stress on any plane, therefore direct stress would be equal to the 100 megapascal. Direct stress would be equal to the 100 megapascal. This is the Mohr circle. Radius of the Mohr circle becomes 0. The strain energy per unit volume required to cause the material to called as a fracture. No, if you just draw the stress strain diagram, for a mild steel, a simple ductile elastic material, so this is the breaking point. The total area, this is an elastic limit or limit of proportionality, slightly different from that elastic limit, and this is the ultimate, and this is the breaking point or a rupture, breaking point or the rupture. This total area, the total area is the strain energy, toughness, and the strain energy per unit volume is called as the modulus of toughness. The strain energy per unit volume means modulus. To cause the material to rupture is called as the modulus of toughness. The total area is the toughness. The the area up to the elastic limit, the maximum strain energy stored per unit volume up to the elastic limit is called as the proof resilience. This is this. Whereas the total area under the stress strain diagram up to the breaking point is the modulus of toughness. Okay. The total area of the stress strain diagram up to the breaking point is called as the modulus of toughness. The strain energy stored per unit volume inside the member up to the breaking point, it is called as the modulus of toughness. And this is also question on the Ashtanta materials. Buckling can occur when the induced stress of course, from the Euler's theory of columns and struts, Euler's the columns and struts. From Euler's theory of columns and struts. So we have different situations, one end fixed and other end free, and one end is fixed and other end is hinged, and both ends are hinged, and different loads are there. Okay, crippling loads, and the loads are basically compressive in nature. Then only it can be called as a column. Okay. Buckling analysis uses the Young's modulus of the material and the moment of inertia, Young's modulus, moment of inertia, and the column cross section area, etc. No, all these and the length, and it's of course a length there. The long columns, very long column easily buckles. That is why it is called slenderness ratio. Slenderness means something connected with the area of cross section versus the length. How long it is and what is the area of cross section. How thin it is, how long it is. That will decide the what is the buckling load or the crippling load. Okay. So that will definitely, all these formulae will be applying in the buckling analysis or the Euler's theory of columns. Second statement is also covered. The load that buckles the column is called as a crushing. No, this is wrong. Crushing thing is a short column. You know, so this is supposing if it is a short column, thick one, and this is the crushing load. Short column of wide cross-sectional area. This will come under the crushing phenomenon. This is wrong. Only 1 and 2 correct. You know that longer the column, area of cross section is too small, too small, thin, slender rod, very long rod, easily buckles. Of course, even under any condition, whether one end is fixed, one end is free, one end is fixed, one end is hinged, both are hinged, four different cases are there. But whatever may be the situation, longer it is and area of cross section is small, easily tend to buckle under the compressive load. 1 and 2 are the correct answers. So this is the regarding the maximum principal strain theory is the Saint-Venant theory is regarding the theories of failures names. We have got the 5 theories of failures, stress cause, von Mises, etc., Coulomb's theory and all that. So different names are asking. This maximum principal strain theory is a Saint-Venant theory, correct. Maximum shear strain energy theory is known as the von Mises and Encke theory. This is also correct. Okay. Maximum strain energy theory is also known as the Guest and this is a Hayes theory. This is the Hayes theory. This is not Guest and Tresca's theory. Third is wrong. 1 and 2 only correct. And maximum. This is the maximum shear. Guest and Tresca's is the maximum shear stress theory. You have to remember the names, Rankine theory, and for generally when you talk about the theories of failure, very widely is asking. In the GATE 24 also there is one question on the theories of failure. So theories of failure, a small chapter, must be remembered chapter, always will be asked in the GATE or IES. Look at the GATE 24 paper, which I had given the solutions 2 weeks ago. There is a question on the theories of failure. You have to remember all the 5 theories of failure, where they are applied, whether they are brittle material or ductile material, whether it is which is more conservative, which can be more practically applied. So all kinds of criteria we have to remember. Only 5 theories of failure are there: maximum shear stress theory, maximum principal stress theory, maximum principal strain theory, maximum shear energy, like that. So all the 5 theories of failure you have to remember with the names and which material they are applied, number 1. And which is more conservative, where you can apply the easily for the what kind of application they can be applied. All these things are very, very commonly asked questions there. So, Guest and Trescott is the maximum shear stress theory, whereas the maximum strain energy theory is known as Hayes theory. So, only 1 and 2 are correct. This is a very simple question. See, strength of materials, though he has asked around more than 12 to 13, most of the questions are quite easy. In fact, this is why this year paper, IES paper is very, very easy paper as compared to the previous. It may mean that the cutoff may slightly increase, but actually, if you look at the IES prelims 23, even the topper, IES topper is able to score around 55 to 60 marks. I'm talking of the these 300 marks of the prelims there. So, even the topper is able to score around 60%, slightly less than 60% of the paper. We do not know, actually it all depends upon the relative performance there, but this paper I will rate it as very easy paper there. Beams with one end fixed and other end is simply supported is a propped cantilever. This is a propped cantilever. One is correct. Beam supported at more than 2 sections or no. Fixed beams is this is a fixed beams. Built in, actual built in, no, this will totally resist the moment. It will twisting moment and any bending or nothing. Everything is this is a fixed beam. Cantilever this is a cantilever. One end fixed, other end is free. This is a propped cantilever. This is a simply supported beam. If you have more than the two supports, it is a continuous beam. There is a loading there. It is a continuous beam. This is a cantilever. This is a simply supported beam. All these basic things he has asked there. This is a continuous beams. This is a propped cantilever. This is a cantilever. Beams with one end fixed and other end free is known as the cantilever. This is a continuous beams. This is not the fixed, rather it is a one end fixed in the sense it is built in. One end fixed and other end free. This is the loading, this is cantilever. This is a propped cantilever. This is a simply supported. This is a continuous beam. More than 2 supports are there. Okay, this is the continuous beams, these are the loadings. So 1 and 3 are correct. Second one is wrong. Second one is a continuous beam, it is not the fixed beam. And if sometimes beam may be both end fixed, well built in a rigid supports, this is both ends fixed. Cantilever, propped cantilever, simply supported, continuous beams, all varieties have drawn there. 22, the effective length is the distance between the points of inflection in the deformed shape of the column, which is referred as the elastic curve. This is correct. At the inflection point or the point of counterflexion or the inflection point, the moment does not change. Bending moment changes sign. Okay, it is that is called as the point of counterflexion or the inflection point. This is wrong. At the transition point, the curvature is changed from the hogging to the sagging or sagging to the hanging, and it is called as the counterflexion point or inflection point there. So 1 and 3 are correct. Effective length is the distance between the points of inflection in the deformed shape of the column, which is referred to as the elastic curve. Yes, correct. Point of inflection or the point of counterflexion is where the bending moment changes sign. Yes, this 23 again is regarding the power transmitted through a circular shaft. Whenever there is a circular shaft is transmitting power, weight is subjected to the torque where D is the diameter, it is under pure shear, right? It is under pure shear. You know that shear stresses vary in the cross section. If you just see the cross section, shear stress is 0 and shear stress is maximum at the periphery. We know that is the diameter, the cross section there. We know that we have the bending moment equation, T by IP is equal to Fs by R. Fs by R is equal to Q maximum divided by capital R is C theta by L, where theta is the angle of twist, shear modulus, length of the shaft. This is the shear stress at any radius R, and maximum shear stress at the radius of the capital R. So this is the torsion equation. The stress and deformation can be calculated by rating power. Power is equal to torque into angular velocity omega 2 pi n by 60. Torque into 2 pi n by 60. It is a power formula. So from the given power, from the speed, and we can calculate the torque. You can substitute here. This is polar moment of inertia. Some books will call it as a J. No, pi to power of 4 by 32 for the circular shaft. Okay, this is R is any radius, and capital R is the radius of the shaft. So power produced by is stated in terms of the, yes, this is also correct. This is also correct. Power is defined as the rate of doing work. 1, 2, 3. What is it? Very simple questions he has asked in this. All are straight. There is no complication. If you just know the basic things, nobody. I never expected in the IES paper what are the types of beams and what is fixed beam, what is a cantilever. They are the very, very elementary questions of very just having the little fundamental ideas, very basic ideas of the Standa materials. Most of the questions can be answered. Where a body is acted upon by the pure shear, same question was asked. Pure shear, this is the pure shear, complementary shear, pure shear at 135 degrees. If this is 45, there is one plane perpendicular to that at 90 degrees. There is another plane. What is the stress? A compressive stress will be induced, which is of the same magnitude. A compressive stress of the same magnitude. Here on this plane, it is a tensile stress. Tensile stress of the same magnitude tau. So this is because the angle between that plane carrying the tensile stress and this plane carrying the compressive stress will be exactly 90 degrees. This is a 90 degrees with no shear stress, no shear stress on these planes. In fact, they are at compressive stress are now no shear stress. They become the principal planes. What do you define a principal plane? How do you define a principal plane? Principal plane is that plane on which there are no shear stresses or tangential stresses. The only normal stresses will be prevailing, and those only normal stresses existing on the principal planes are also known as principal stresses. Okay. So there is no shear stress on this, but that compressive stress is exactly equal in magnitude to this shear, pure shear. Answer is B. On this there is a tensile, on this there will be a compressive. Ability of material to regain its original shape after removal of the load. Actually, it is a property of its nature is called as the property of elasticity. Elasticity is the property of the material by virtue of which the elastic member would be able to regain its original shape and size after the load is removed. Okay, up to elastic limit. Of course, there is a limit there, beyond which there will be a plastic the material yields and material will undergo some plastic deformation. There will be a permanent set. Up to elastic limit, whatever Hooke's law is valid. Okay, and the ability to regain its original shape. This is actually when you call it about the property proof resilience, or sometimes actually both A and B looks to be answered there. What is the proof resilience? The area under the stress strain curve. The area under the stress strain curve up to the elastic limit. Supposing if this is the elastic limit, the stress is directly proportional to strain within the elastic limit. The area under the stress strain curve on the x-axis. This is the strain energy, maximum strain energy, which is also called as the maximum strain energy stored up to elastic limit per unit volume. This is also only called as proof resilience or modulus of resilience. In fact, answer is A. Sorry, this is a modulus of resilience. And the maximum strain energy stored up to the breaking point, it is called as a modulus of toughness. Strain energy per unit volume means modulus, right? So that is the property of the material. You can take resilience or the modulus of resilience. Both B and C looking to be closer. Maximum strain energy stored up to elastic limit per unit volume. This area could be called as the modulus of resilience. Now coming to the thermodynamics, which of the properties is not an extensive? Not an energy is an extensive. Energy extensive means what? Depends on mass. Depends on mass. Which don't depend on the mass, it is called intensive. Energy, this is extensive, this is extensive, this is extensive, only this is intensive. So answer is D. This is odd man out. All three are extensive. Only P and T are intensive. And incidentally, are the specific internal energy, specific enthalpy, specific entropy, all the specific volume, again all are specific quantities. All specific quantities are intensive again. Please remember this point. They are all defined per unit mass. Kilojoule per kg, this is kilojoule per kg Kelvin, this is meter cube per kg. All are specific quantities. There again are intensive. The total quantities, internal energy, capital H, capital, these are extensive. But when they are defined for unit mass, the small letters, specific, they are called as a specific. Specific means which are defined per unit mass. They are again intensive. Supposing if he has asked the specific enthalpy, that is intensive. If he has asked the specific volume, again intensive. What is specific internal energy? Again intensive. Okay. Total quantities are extensive. So answer is D. It's a very simple question. Two cylindrical containers are volume, two equal volumes, 2 meter cube. 2 meter cube, pipe with a valve between them. The valve is closed and this is 20 kg air, this is 4 kg air. 27 degrees Celsius. Both are at 27 degrees Celsius and perfectly insulated, thoroughly insulated, no heat transfer, nothing. What is the final pressure in the vessel after the valve is opened? After they attain mechanical equilibrium, initially they are at thermal equilibrium only, 27 same temperatures. Once the valve is open, maybe there will be a mass transfer and finally things will settle down. Neglecting this little volume in this transiting pipe, what is the total volume after the thing settled? 4 meter cube. What is the temperature finally? 27 degrees Celsius. What is the total mass? Total mass after the valve is opened, 20 plus 4, 24 kg. Then we can write the ideal gas equation. Air is an ideal gas. PV is equal to MRT. Therefore, P is equal to MRT by volume. Mass is 24.287. Gas constant of air. Temperature is 27 plus 273. Air is an ideal gas. This is an ideal gas equation. Air is an ideal gas. Ideal gas equation divided by total volume is what? 4 meter cube. You will get the answer. Pressure in kilopascal, 516.6. Initially, the system is in thermal equilibrium, but not in mechanical equilibrium, because pressure may be different here, pressure may be different. But once the mass transfer happens, once the things will settle down, both will attain the mechanical equilibrium, same pressure after a valve is opened. Neglect this little volume of that connecting pipe, and the total volume will be 2 plus 2, 4 meter cube. Thermoelectric thermometer. Thermometer works on the principle of Seebeck effect. Thermoelectric refrigeration, thermoelectric, what is the thermoelectric, what Seebeck effect? When two dissimilar metals are joined, when these two junctions are maintained at different temperatures, there is a EMF generated. There is EMF generated. Two dissimilar metal, wire 1, wire 2, dissimilar metals. Two different junctions are there, T1 may be greater than T2, there is an EMF generated. This effect is called Seebeck effect, and the reverse of this effect is called Peltier effect. Peltier effect only is used in the thermoelectric refrigeration. Seebeck, reverse is Peltier effect. So, when this effect, Seebeck effect says that when two junctions are maintained at two different temperatures, there is EMF generated. That EMF generated is directly proportional to the temperature difference. That EMF generated is again depends upon what materials you are taking. There are different combinations, iron, iridium, constant, iridium, titan, like that. Different combinations are there. Okay, that EMF generated is dependent upon the what combinations of the materials you are selecting. Isentropic expansion efficiency is very in any gas turbine power plants or steam turbine power plants, isentropic means what? Reversible adiabatic. The actual expansion work will be definitely lesser than the ideal work. 1, 2 dash, this is 2. Isentropic efficiency of the turbine expansion is H1 minus H2 divided by H1 minus H2 dash. Usually it is around 0.9. Actual expansion work divided by ideal. Ideal, this is an ideal. This is actual. This is ideal. Ideal means isentropic. Very simple question. Very simple. Usually it will be around nearer to 85 to 0.85 to 0.9 like that. This holds good in both gas turbines and as well as the steam turbines. Same definition. This is the isentropic efficiency. Some books will give it as the adiabatic efficiency. That is not correct. More correctly, it is isentropic efficiency. In the reheat cycle, principal advantage to increase the quality of steam. See, this is a power plant. So many questions being asked in the ES, and in this year GATE also they have asked the 5 questions, 5 marks I guess. They have asked the question from gas turbine power plant and as well as the steam turbine power plant, GATE 24 also. I have discussed about 2 weeks ago. I had given the paper solutions of the GATE 24. And what is the purpose of reheating on a Rankine cycle? This is because the steam means Rankine cycle. What is the purpose of reheating? Actually, the main purpose of reheating will be to eliminate that excess moisture during the later stages of expansion, particularly when higher boiler pressures are used. Particularly when higher boiler pressures are used, why you are looking for higher boiler pressures? To attain more efficiency. I already said in my classes that as the boiler pressure is increasing, thermal efficiency of the Rankine cycle will increase. But that increase of boiler pressure will have the, no doubt efficiency will increase, but there is another danger coming along with it. What is that? After the expansion, when you are employing higher boiler pressures, the steam may become too wet. The steam may become too wet, may cause the erosion. Here this may cause the erosion, because the lowest dryness fraction values permitted is 0.9 or 0.88. In any steam turbine, the lowest dryness fraction values permitted is 0.88. If it is more than 12% moisture or less than dryness fraction values are less than 0.88, there is an erosion of turbine blades. erosion of steam turbine blades. That will cause turbine blades if X value falls less than 0.88 or 0.9. X is the quality or dryness fraction or quality of steam. So, to avoid that one, if you do the reheating, this is called reheating. Reheating and then allowing it to expand in the low pressure turbine. You have the two turbines here, high pressure turbine and low pressure turbine. Then look at this. This point has moved to here. So their dryness fraction values are increasing. No erosion danger. No danger of the erosion. Therefore, the principal advantage of is to increase the quality of steam at a turbine exhaust, thereby to prevent erosion at the turbine exhaust, to increase the quality. Quality means what? Dryness fraction or quality, both mean the same. You can look at this. Answer is A. See, Rankine cycle questions are very common in both GATE and IS. This year GATE 24 also has asked the questions on the Rankine cycle, how to improve the efficiency. There are many ways. Regeneration, reheating. Reheating may not increase efficiency all the time, but most of the times it will increase. Sometimes it may decrease also, that is a different point. Regeneration, etc. by increasing the supply steam temperature. See, Rankine cycle, what is the Rankine cycle thermal efficiency? Work of turbine minus work of feed pump divided by heat supplied in boiler. Thermal efficiency of the Rankine by reducing the heat addition in boiler. Yes. By increasing the steam turbine expansion work. Yes. By reducing the PIM part. Answer all the three. Answer is C. Work of turbine minus work of pump divided by heat supplied in the boiler. So answer is C. What is the actual pressure of air? Again the fluid mechanics. Compressed air measured by manometer is 30 centimeters of mercury and atmospheric pressure. Obviously, actual pressure means E means absolute pressure only, not the gauge, because he has given the atmospheric pressure. He wants the total because all the pressures are more than 101. He is asking the absolute. Absolute means what? If this is atmospheric pressure, any pressure more than the atmospheric pressure, it is called as the, by what extent it is more, it is gauge. This is called as the absolute pressure, P atmospheric pressure plus P gauge. This gauge pressure can be calculated like this. P gauge, here it is given as 30 centimeters of the mercury, that is rho GH. No, this is the rho is density is rho, no, 13,550, 9.81, H is 30 by 100. This is the gauge, so many Pascal. So many Pascal. So calculate the atmospheric, that is divide with 1000, you will get in kilopascal. Okay, this is 101 kilopascal. You add both. 101 plus this is gauge. P gauge we have calculated. You will get the absolute pressure as 140.76 kilopascal. Answer is C. Then the questions coming from the heat transfer. Heat transfer has asked about 8 to 9 questions. All are easy. Very easy questions asked. Two-dimensional steady state. Steady state means what? Temperature is not a function of time. Steady state. And no heat generation. Q dot is 0. Okay. A generalized conduction equation is, this is the generalized conduction equation, right? Dou square T by dou Z square plus Q dot by K and 1 by alpha into dou T by. Steady means this is 0. This is 0. No heat generation. Q dot is heat generation per unit volume. 2-dimensional, this is 0. This is 0 means 2-dimensional. Answer will be D. Straight question. This is a generalized conduction equation where alpha is the thermal diffusivity, K by rho Cp, K by rho Cp. This is a Rayleigh number. Rayleigh number, Grashof number, where would you come across in heat transfer? You will come across the Rayleigh number, Grashof number only in the free convection heat transfer. Free convection or natural convection. Free or natural convection only we come across this. How do you define Rayleigh number? Product of GR and PR, Grashof number. And correct about the relation among the Grashof number. Rayleigh number is GR/PR. Okay. Product of the Grashof number and Prandtl number is called as the Rayleigh number. What is the Grashof number formula? G beta delta T L cube by mu by rho whole square. This is a Grashof number. What is the Prandtl number? Mu Cp by K. Is a property, mu Cp by. The product is called as the Rayleigh number. A is answer. He is comparing when the free convection currents are dominating, when the forced convection is dominating. See, convection heat transfer is the mode of heat transfer occurring between a solid body and the surrounding fluid due to the temperature difference. If the fluid has got some finite definite velocity, measurable velocity, it is called as a forced convection. If there is no velocity, finite velocity not observed, but still there is a motion of the fluid over the body, it is called as a free or a natural convection. Motion is there. In the free convection also there is movement, motion. You can see with your naked eye also that motion, but motion is slow, pretty slow, not having a definite velocity. But if the definite velocity persists, it is a forced convection. Then what will cause the motion of the fluid in free convection? The buoyancy forces arising out of the density changes of the fluid. So, free convection also motion is there, forced convection also motion is there, but in the forced convection there is a definite finite given velocity, V will be there. That is why we see the Reynolds number. We see the Reynolds number, Vd rho by mu or VL rho by mu. If in case of the flat plates, if it is a pipes, okay, Reynolds number will be there. But there are certain situations where both convections will be prevailing, forced and as well as the free. But we can neglect the forced convection, you can treat the problem as free convection in case if the criteria is Grashof number by Re square. If it is far greater than 10, that means Grashof number is dominating. Grashof number just now is defined. Grashof number is buoyancy force by viscous force. Whereas the Reynolds number is the inertia force by viscous force, we all know that. So this is the criteria. If it is far greater than means only free convection. Only free convection, we have to treat the problem as only free convection. If GR by Re square is far lesser than 10, it is the forced convection. If in between there, it is both free and forced. Answer is free convection is of primary importance. If in between this is GR by Re square is in the vicinity of 10, then we have to consider both forced and free. So the criteria is the ratio between the Grashof number divided by square root of the Reynolds number. Okay. Grashof number you see only in the free convection. Reynolds number you see only in the forced convection. Okay. If there are situations where there may be a mixed convection will be there. So when the GR by Re square in the near the range of the 10, then we will have both forced and free convection. And blindly you can remember that if you read velocity in the any convection problem, it is a forced convection you take. If you don't read any velocity, you go to the free convection problem. Treat it as a free convection problem. Monochromatic, if epsilon lambda is not a function of lambda, very famous definition, it is a grey body. Kirchhoff's law, emissivity is equal to absorptivity. This is absorptivity. Kirchhoff's law says that this is emissivity. A good absorber is always a good emitter. This is the answer is C. You take it as alpha. A good absorber is always a good emitter. A good absorber is always a good emitter. Kirchhoff's law states that whenever a body is in thermal equilibrium with its surroundings, its emissivity is equal to its absorptivity. Whenever a body is in thermal equilibrium with its surroundings, its emissivity is equal to its absorptivity. Alpha is equal to epsilon, that is called Kirchhoff's law. This is a problem regarding the material science and metallurgy there. So answer is A. Material science, see every year material science and metallurgy, they will ask minimum 76 to 7 questions in the ES. But whereas in GATE, there is only one question, only one will appear, maximum one. One question in the GATE, material science. In IES, they ask about sometimes 7, sometimes 8, even beyond that also. Material science is important in the IES point of view, but not in the GATE. But you have to know the subject, unless otherwise the material science is there, we can't understand many of the production related subjects. One should have a, because that is a basic engineering science, material science and metallurgy. So, but weightage is usually very less in GATE, maybe 1 mark they may. In this year also I think they also asked 1 mark regarding the iron carbon diagram, etc. Here the answer is A. Next question, 2 questions are regarding the ionic compounds and covalent compounds. Here consider the following statements regarding the ionic compounds are generally crystalline in nature. Yes, correct. They are generally insulators but non-conductors of electricity, and they are insoluble in organic solvents but highly soluble in water. That is also correct. All 3 statements are correct regarding the ionic compounds. Next thing is asked about the covalent compounds. They can exist in all states of matter. That is correct. They are generally electric insulators. That is also correct. And they are insoluble in water but soluble in non-polar solvents such as benzene and alcohol. That is also correct. Answer is D. All 3 statements are correct. All 3 are correct in this 40th question. This is X-ray diffraction. They said because 2 or 3 questions is asked about the X-ray diffractions regarding the material science. X-rays are not deflected by electric or magnetic field because X-ray themselves are the electromagnetic radiation. Like thermal radiation is an electromagnetic radiation, like X-rays, gamma radiation, UV radiation, they are all electromagnetic in nature. So this is correct. They produce fluorescence in many substances. You can recall that cathode ray experiments which were learned in 12th class, 11th class rather. They are highly penetrating and destructive. Yes, too much of X-ray exposure of our living tissues, they may damage. Too many X-rays if you are doing particularly when bone fractures and all, you want to detect, you go rely on X-rays. But too much of X-ray exposure, living tissues will definitely get damaged. All the 3 are correct, 1, 2, 3. You can recall the cathode ray oscilloscope or cathode ray experiments regarding the X-ray. Next question is also as asked the X-ray diffraction. To investigate the structure of the crystalline solids, that is correct. to study complex organic compounds by analyzing their structures. Yes, organic compounds, their structure is analyzed by using the X-ray diffraction methods to find the atomic numbers and energy levels to identify the elements. You may recall the many experiments which was conducted long ago in the applied physics regarding the X-ray, how the X-rays are used, how the X-rays are produced, etc. And all three are correct. This 41 and 42, both the questions are asked only how the X-rays are used in our mechanical engineering as such, particularly regarding the material science applications. All 1, 2, 3 are correct. 43, molybdenum. Influence of molybdenum element in steels imparts a higher temperature in strength, enhances resistance to creep, minimizes temperature brittleness. Okay. As the temperature changes, high temperatures, that may induce the brittleness. Adding the molybdenum, that effect will get minimized. All the questions, all the answers are correct. Particularly when the high temperature applications are there, molybdenum is wanted, deliberately is used to get all these benefits by adding the molybdenum to the steels. 44 is the alloying elements of tungsten based tool steels are chromium, vanadium and cobalt. 45, consider the following disadvantages of Loy methods. Various reflections may make the appearance of the photograph complicated, that is correct. Due to the wide range of wavelengths, there is overlapping of the diffraction images, that is also correct. There is a variation of incident X-ray beam due to the large range of wavelengths, that is also correct. All three are correct regarding the disadvantages of the Loy methods. Optical pyrometer works on the principle of thermal radiation. This is Wein's displacement law. Wein's displacement law. See, there is a strong relation between the temperature and the wavelength, maximum wavelength of emission. Just by calculating the noting the wavelength of emission, we are able to calculate the temperature. This is called as the optical pyrometer. Very high temperature measurement. So thermocouples and all, they can measure up to 1000 degrees Celsius. Say for example, sun temperature. What is the temperature of the sun, which is treated as a black body? 5800 K. Sun is treated as a black body. Its temperature is 5800 Kelvin. How did you measure the sun temperature? Just by noting the wavelength at which the monochromatic emissive power is maximum at that. Because for the black body there is a specific character is there. This lambda m is shifted to the shorter wavelengths. For a black body, the monochromatic emissive power will shift to the shorter wavelengths. That is why this equation, Wein's displacement, lies there. Optical pyrometer can measure the temperature of the body without touching that body. Usually it is used in the casting industries. Casting foundries, casting industries, where the high temperature is required to be measured. Supposing there is a molten metal at a temperature of 3000 Kelvin. My instrument cannot tolerate, thermometers cannot tolerate, thermocouple cannot tolerate. These are all the temperature measuring devices. And then how to measure the temperature of that? I will just put my spectros by using the spectrometry. I can tell what are the wavelengths emitted by that body. By recording that wavelengths, I can guess what is the temperature of that body without touching that body. That instrument is called as the optical pyrometer. It uses the thermal radiation phenomenon, particularly the Wein's displacement law. Because there is a strong link between the temperature of the body. Supposing this is T1, this is T2, this is T3. T1 is greater than T2 greater than T3. At higher temperatures, most of the radiation will be emitted to the shorter wavelengths. This pyrometer only uses the principle that as the temperature of the body is higher and higher, most of the radiation emitted from that body will be shifted to the shorter wavelengths or smaller wavelengths. Higher the temperature of the body, shorter the wavelengths of emissions. Most of the, not all I can say, most of the thermal radiation emitted from the body will be at a shorter wavelengths. Sun is the best example. So most of the solar radiation would happen at the short wavelength range of the thermal radiation. Thermal radiation is 0.1 to 100, but most of the solar radiation will be at the short wavelength radiation because the temperature of the sun is very high. Sun is treated as a black body. 47th question, it is the heat treatment defects. See, heat treatment, oxidation, warping, that is correct, quenching cracks, all three are correct. Defects of the in steel due to the heat treatment. Oxidation, you see, as the temperature body of the body is steel is increased, the oxidation tendency of all the metals will increase. They form the oxides, okay. That oxidation tendency will be higher and higher if the temperature is higher. So answers are both 1, 2, 3. This is also material science question. Powder, this is a question based upon the powder metallurgy. It must be possible to form a continuously bonded matrix. That is correct. Metal in the powder form must be able to respond to a solid phase welding. No, actually this welding cannot be, no, welding is a different phenomenon. Solid phase welding is a different phenomenon, okay. So powder metallurgy doesn't apply to that particular thing. Powders in which the basic materials are available must be sufficiently close packing under pressure. That is also correct. 1 and 3 are correct. See that he has used the word welding, respond to the solid phase welding is altogether a different phenomenon. The powder metallurgy, but that is a different domain. Regarding the mechanical properties of the materials, the phenomenon leading to a fracture under repeated stresses, cyclic stresses. This is called as the cyclic stresses having the maximum value less than the ultimate strength of materials is called fatigue. It is not called as a creep, it is called as a fatigue. If it is fatigue is given, that is correct. A time temperature parameter related to predict the stress rupture under the creep is called Larson-Miller parameter. That is correct. Time dependent deformation of a material when subjected to a constant load of stress is called as, in fact this is known as the creep, not the fatigue. So 3 is also not correct, only 2 only, answer is 2 only correct. First one is wrong. First one is wrong statement. It is not creep. If it is given a cyclic fluctuations is called creep. If it is given a fatigue, then it could be correct. A material may fail under the cyclic stresses, that means positive, negative fluctuations. In a small time the stresses are fluctuating from compressive to the tensile. That kind of a cyclic variation in the stresses, material may fail even if the stresses are less than the ultimate stress. The process of atoms moving over each other during the permanent deformation of a metal is called slip. All 3 are correct. The ability of some metals to deform plastically by 1000 or 2000% at high temperatures at low loading is called as a superplasticity. That's correct. An empirical equation, strength of material to its grain size known as Hall-Petch relationship. That is also correct. 1, 2, 3, all 3 are correct. This is also a question regarding the mechanical properties, or you can say material science there. So these are the questions on the IC engines. Generally in this year gate, IC engines was not asked anything. I don't remember anything, gate 24. Usually they ask one question regarding the thermodynamic cycles, auto, diesel or dual, etc. But this year he has not given gate in the gate. Here he has asked 4 to 5 questions. It is a Rolls-Royce turbocharged 4-stroke direct engine diesel engine. Displacement is given. Engine has a maximum output of Power was given 900 kilowatts. At speed is given. What is the brake mean effective pressure? First of all, how do you define the mean effective pressure? Mean effective pressure is net work done per cycle divided by stroke volume or displacement volume. This is the definition of the mean effective pressure in the IC engines. Of course, again there are two mean effective pressures, indicated mean effective pressure and the brake mean effective pressure. Obviously, PM brake is lesser than BMEP, brake mean effective pressure is lesser than indicated mean effective pressure. Okay. But how to calculate, what is the relation between power and the brake mean effective pressure? PM LA, that is a stroke volume, into N by 2 divided by 60 into K. This is the stroke volume of each cylinder. This is the formula to calculate the power, stroke volume. K is the number of cylinders. This is for 4S engine only. Obviously, 4S engine, for 4S engine is K is the number of cylinder for 4S engine. Okay. All the multi-cylinder engines by default are the 4-stroke engines. N is the NA is the stroke volume. Power is given, displacement volume was given, that is for all the 4 cylinders. For all these cylinders, he has given the displacement volume. Power is given as 900 PM brake, LA 26.1 into liters as given, 10 power minus 3. Speed is 2300 divided by 2 because he has given the V stroke for all the cylinders. For all, this is for all the cylinders put together, divided by 60. So you will get the PM in kilopascal you get, divide with 100, you get the answer in bar. This is the formula for the power output. PM LA N by 2 by 60 into K. LA into K has been, K is the number of cylinders, LA is the stroke volume. This 26.1 I have converted into the meter cube, that is why I multiplied with 10 power minus 3. This is kilowatts. This PM you will get the answer in kilopascal. 100 kPa is 1 bar. Answer is given 1 bar there. Answer you got is 18 bar. 18 bar. After getting the kilopascal, divide with 100. Answer is A. This is a question on the IC engines. High performance 4-stroke engine. Compression ratio is given 10:1. Ideal air standard efficiency given. Auto cycle is 0.602. Indicated efficiency is 55% of the auto cycle. The engine mechanical efficiency is 85%. Volumetric efficiency is 90%. Okay. The calorific value of the, what is the engine arbitrary overall efficiency? See, indicated thermal efficiency was given. Usually indicated thermal efficiency will be usually half of the air standard efficiency. This is the air standard. Indicated thermal efficiency, usually it is half of the air standard efficiency. This is the air standard. This ratio is only known as, this 0.55 only is known as relative efficiency. This 0.55 can be called as the relative efficiency. 0.55 into 0.602. That is the indicated thermal efficiency. Okay. And the mechanical efficiency. So therefore, brake thermal efficiency will be mechanical efficiency into indicated thermal efficiency. Okay, that is 0.85 is a mechanical efficiency. Mechanical efficiency will take into account the frictional losses. What is the significance of mechanical efficiency in IC engines? It will take into account the frictional losses. What is the indicated thermal efficiency? 0.55 into 0.602. Okay. 0.5 into 0.31, 0.3 into 0.5, it will be near to the 28.1, I guess. This is, I think this is the answer is 28.1. This is the overall efficiency. What is the engine arbitrary overall efficiency? He is asking, otherwise asking the, other way is asking the brake thermal efficiency, I can see. Final, what is the brake thermal efficiency? Brake power output, final brake power output, final shaft power output divided by heat supplied per second by the combustion of the fuel or the diesel. So 28.1, I guess answer, that is 0.55 into 0.602, that is 0.3 roughly, 0.3 into 0.85. I think 26, the answer should fall between these two. I think answer is 28.1. That is the final answer, you can say. Performance, this is a question on air conditioning and refrigeration. There are many questions are asked on the R&AC. The performance test of an air conditioning unit, this is the rated head, rated tonnage, indicating poor cooling. The test on a heat rejection atmosphere in condenser shows the following: cooling water flow rate, water temperature, power input. See, this is a AC system. It is extracting heat from the low temperature and giving to the high temperature. AC or refrigeration system, both will operate on the same principle, right? This is the Q rejected in condenser. And the power input to motor is given, that is 48 kilowatts with the 95% transmission efficiency. Power input to motor, but all that will not go there, into 0.95% losses will be there from the motor to the compressor. He is asking, what is the Q rejected in the condenser? Mass flow rate of the water, Cp of the water, change in delta T of the water. Okay. Mass flow rate of the water, delta Cp of the water, that is can be calculated. 4 liter means 4 kg. Cp of the water given 0.1868, temperature change is 40 minus 30, so many kilowatts. So many kilowatts is the heat rejected in the condenser here. This is the Q rejected in the condenser, this is the power. He is asking, what is the Q absorbed? Q absorbed is asking. What is the Q absorbed? What is the actual refrigeration capacity? This is the refrigeration capacity. Okay. So according to the first law, you can say first law of thermodynamics, Q absorbed from low temperature, that is equal to refrigeration capacity, should be equal to, this is going, this is going into the system, that should be equal to the Q rejected in condenser minus power input, that is minus power input. Answer will be 120. This is the power input, is this one. This is the power input. This one we got the Q rejected in condenser m dot Cp into, we know that 4 liter is 4 kg per second. This also will be in kilowatts. This minus this answer will be 121.9 kilowatts. Actually rated capacity is 140, but it is not functioning well. Actually it is giving the refrigeration capacity of only 121.9. He has tested what is the Q rejected in the condenser, because Q rejected in the condenser is nothing but the heat taken by the cooling water, because in the condenser the cooling water, cooling water in, cooling water out, it takes the heat in the condenser. So the cooling water in and cooling water out, the heat taken by the cooling water is the heat rejected by the refrigerant in the condenser. Okay, this is the AC unit. Power input is given. So this plus uh, the sum of these two, look at this, the sum of these two, this is energy going into the system, this is the energy going into the system, the sum of these two should be the Q rejected. So first I calculated the Q rejected in the condenser minus the power input will give the refrigeration capacity, the heat absorbed by the refrigerant in the evaporator. That answer is 121.9. C is answer. Next question is regarding the air conditioning. Partial pressure of the vapor was given 12.79 mmHg. Barometric pressure was given, total pressure 736 mmHg. What is the specific humidity? Specific humidity W will be equal to the 0.622 into PV by PB minus PV. This is the humidity ratio, also known as specific humidity. Humidity ratio, also known as specific humidity. Very famous formula in air conditioning and psychrometry. kg of water vapor per kg of dry air. So answer will be 0.011 kg of water vapor per kg of dry air. PB is the total barometric pressure. Very standard formula. If 1 meter cube of gas is compressed in a reciprocating compressor, this is the reciprocating compressor. Reciprocating compressor is an open system. This is the PV to the power of gamma is equal to constant. Suction, compression and delivery. This is the adiabatic compression, right? So open system, work done by open system, steady flow open system during a reversible process is minus integral VDP. The area, this area, no? Area of PV curve on y-axis. Thermodynamically, area of PV curve on y-axis is the minus integral VDP. Work of compression will be gamma by gamma minus 1 into P1 V1 after integrating gamma minus 1 by gamma minus 1. This is the answer. You substitute all these things, you will get the answer. Gamma is 1.4. P1 is 100 kilopascal. V1 is 1 meter cube. You will get the answer in kilojoules. Multiply with 10 cube, you get the answer in joules. 55 is into 1 bar is 100 kilopascal into 10 cube, answer will be 204050 joules. Answer is D. Nearer value you get, not exactly. But here because I substituted in kilopascal, I get the answer in kilojoules. That multiplied by 10 cube, the answer will be getting in. Minus integral VDP, this area will be the minus integral VDP. Work done by steady flow open system during a reversible process is given by minus integral VDP. This is the formula. The compression process is PV to the power of gamma is equal to constant. A R134 thermostatic valve, thermostatic expansion valve, TX valve they also called as the TX valve also they call, is not equipped with an external equalizer, has a superheat. See, there are three kinds of the expansion valves or throttling valves are there. Automatic expansion valve, thermostatic expansion valve, capillary tube, float valve. There are varieties are there in the VCR system. In the vapor compression refrigeration system, there are varieties of the expansion valve there. This is the throttling device. Varieties of the throttling devices are there. This is the process throttling valve. That what is the purpose of that throttling valve? To control the mass flow rate. To control mass flow rate of refrigerant through evaporator. This is an evaporator, right? This is the condenser pressure. The purpose of the throttling valve, there are 4 varieties are there: thermostatic expansion valve, automatic expansion valve, capillary tube. The most commonly used expansion device or throttling device is the domestic refrigerators. The most commonly used throttling device or expansion device in the domestic refrigerators is capillary tube. Very simple. Capillary, lengthy tube having a narrow hole drilled all along its length. All the domestic refrigerators and window air conditioners, they use the capillary tube. But for the milk chilling units, etc., where the temperature control is very much precise, required to be precise, we may have to use the thermostatic expansion. What does it, how does it work is, thermostatic expansion valve maintains a constant degree of superheat for the refrigerant at the end of the evaporation. At the end of the evaporation, it maintains a constant, this superheat temperature is very, very precisely maintained by the thermostatic expansion. There is a bulb will be there. There is a bulb that will be monitoring this superheat temperature. This is evaporator pressure. This is the condenser pressure, corresponding to which there is some pressure is there for the refrigerant. That pressure is always maintained corresponding to the superheat temperature. Right? So, thermostatic expansion valve, the principle is thermostatic expansion valve maintains constant degree of superheat. Constant degree of superheat for refrigerant vapor, at the exit of evaporator. Always maintain, supposing if the temperature is increasing, immediately the valve opens and allows the flow to happen. If the temperature is decreasing too much, and again it will try to stop the flow. So, this flow rate from the condenser to the evaporator, it is maintained by maintaining the constant degree of superheat. One bulb will be there, that will be maintaining a constant degree of superheat. So, if you just write the pressure force balance, this is the diaphragm. This is the diaphragm of the valve. One side there will be a bulb pressure. That bulb is directly connected to this. This is the bulb. Bulb is monitoring to this bulb pressure, and this is the evaporator pressure. One side evaporator pressure will be there. But there is a pressure equalizer will be there, but there is only one pressure equalizer will be there, spring. There is a pressure equalizer. Spring pressure will be there. Actually, in all the regular thermostatic expansion valve, spring pressure or equalizer will be there. But in this case, not equipped with external equalizer. So this is not there. This is not there now. Spring pressure is not there. So, okay, what is the difference in pressure opposite sides of the diaphragm required to open the valve? What is the pressure difference is asking. Evaporator pressure given. Evaporator pressure is at 0 degrees Celsius. This is 0 degrees Celsius. This is 0 degrees Celsius. This is 7 degrees. Here the temperature is 7 degrees. This is the degree of superheat will be 7 minus 0, 0 degrees. So, bulb pressure is at 7 degrees. Evaporator pressure is at 0 degrees Celsius. Take the difference, that is answer will be 3.748 minus 2.8. Answer is C. So, what is the pressure here? This is 2.928. Evaporator pressure is 2.928. bar. What is the corresponding to the bulb? The pressure acting is 3.748. 3.748. The difference will be 0.82 bar. There is no equalizer. Spring actually there will be equalizer will be there. Not equipped with an external equalizer. It is not working maybe. Then what is the pressure difference acting on the diaphragm? This is the diaphragm. One side of the diaphragm there is an equalizer or the spring pressure, evaporator pressure. On the other side it is a bulb pressure connected to the exit of the evaporator, refrigerant, where the entry to the compressor. We can say entry to the compressor. This is a compressor, right? It's a very good question. Thermostatic expansion valve is used in the milk chilling units, which it maintains, the main principle is it maintains the constant degree of superheat for the refrigerant at the exit of the evaporator. There will be one bulb. The bulb will be monitoring the temperature. Corresponding to that pressure, refrigerant pressure is given as 3.748. Answer is 0.82. A machine working on the Carnot cycle, Carnot refrigerator. This temperature is 260, Carnot refrigerator. This is 305 Kelvin. What is the COP when it is offered as a COP of the Carnot refrigerator is, this is TH, TL by TH. Very routine, regular question, very simple question asked there. Answer is 6.78. D. This is the Carnot refrigerator. A cold storage plant is required to store the fish. Fish is supplied at a temperature of 30. High temperature is 30. Low temperature is -8. Plant requires 75 kilowatts to drive it. What is the capacity of the plant? Actual COP is 0.3 COP of the Carnot. First let me get the Carnot COP. Anti-clockwise cycle, this is low temperature is -8 plus 273. High temperature is 30 plus 273. COP of the Carnot will be TL by TH minus TL. COP actual will be 0.3 of the ideal COP. 0.3 of the COP of Carnot. We can calculate that actual COP. COP actual will be, COP actual we got it there. It is the refrigeration capacity divided by power. Divided by power input. From which power input has been given? 75. This is the power input. Right? You will get the refrigeration capacity. So answer is, I got 44 point, no, refrigeration capacity you get in kilowatts, divide with 3.5, because 3.5 kilowatts, remember that 1 ton is equal to 3.5 kilowatts of refrigeration capacity. You divide with 3.5, I got the answer as 44.8 tons of refrigeration, TR. 44.8 TR. Answer is C. You get the first answer in kilowatts. Divide with 3.5 because 1 ton is 3.5 kilowatts. 1 ton capacity, refrigeration capacity means 3.5 kilowatts. Answer is 44.8. I got the Carnot COP multiplied with 0.3. I got the COP of the actual. COP of the actual of refrigeration system is refrigeration capacity divided by power input. On a particular day, atmospheric air records 9.62 mm of Hg, partial pressure, and saturation partial pressure of vapor is 31.8 at dBT, at dry bulb temperature. Barometric pressure is 756 mm of H. All are mm of Hg. What are the relative humidity? RH5 straight formula is there in the psychrometric relations PV by PS. 9 all are in mm of Hg. You will get one answer. And W will be very standard formula 0.622 into PV by PB minus PV. PB is the barometric pressure, PV is the partial pressure. PB is given, PV is given, PS is given, everything is given. So answer will be A, 0.008. This is 30.25% RH. This is kg of water vapor per kg of dry air. Specific humidity symbol is W, humidity ratio, no, on the psychrometric chart. You will see on the y-axis, right? This is the specific humidity on the psychrometric chart. A is the answer. He has asked a good number of questions on the refrigeration, about 6 to 7 questions I have asked there. A small water cooled condenser uses 13 to the evaporator duty is 4.2 and the motor output is 1.7. What is the water mass flow rate? It is a refrigeration system. See, the evaporator duty Q absorbed from the evaporator is 4.2 kilowatts. It is a refrigeration unit because he has got the evaporator there. Motor power input, motor output or power input from the motor is 1.7 kilowatts. Therefore, Q rejected in condenser according to the first law, Q rejected in the condenser to cooling water. Okay, this should be equal to the 1.7 plus 4.2 kilowatts according to the first law. This is arrow going, this is arrow going in, this arrow going out. This should be the sum of these two. First law, this is only called as first law of thermodynamics. So 4.2 plus 1.7. Okay. Therefore, mass flow rate of the water, Cp of the only water is taking this heat into temperature rise delta T of water should be equal to the 1.7 plus 4.2. Everything given. Mass flow rate of the water into 4.187 into 24 minus 13 is equal to 4.2, 5.2, 5.9 kilowatts. So mass flow rate of the water will be 0.13 kg per second. Answer is D. According to the first law, the arrows entering the cycle should be arrows leaving. That is the first law of thermodynamics, law of conservation of energy. Air circulates, it is a heat exchanger. Think of. Air circulates at the rate of 68, heated from 16 to 34. What is the water mass flow rate for the air heater coil having the hot water entering at 85 and leaving at 74? So water is rejecting and air is picking up. Heat Q lost by water is equal to heat gained by air. Simple energy balance. Okay. Mass flow rate of the water, Cp of the water, temperature drop is 85 to 74. Mass flow rate of the air, Cp of the air into temperature rise 34 minus 16. It is some simple and heat exchanger. Heat exchange from energy balance. From energy balance for steady state. From energy balance, heat lost by the rate of heat lost by water should be equal to the rate of heat gained by the air. Everything is given. You will get the what is the water mass flow rate? Mass flow rate of the water you get 27 kg per second. Cp of the water, everything given, Cp of the air given, Cp of the water given. This is the Cp of the water, this is the Cp of the air, 27 kg per second. From energy balance, the rate of heat lost by the water should be equal to the rate of heat gained by the air. Only there is a heat exchange taking place between the water and the air. Water is losing heat, air is gaining the heat. Okay, the rate of heat lost by the water should be equal to the rate of heat gained by the air, because nothing is given out. There is no energy exchange between the heat exchanger and the surroundings. All the heat lost by the water, all that heat is taken by the air only. mCp delta T, m dot Cp into delta T, it is the rate of enthalpy change either for the water or for the air. A 6-cylinder, it is again IC engines. BSFC given, brake specific fuel consumption. BSFC is fuel consumption in kg per hour, definition is this, divided by brake power output, divided by brake power output. This is the definition of the BSFC. 0.2 kg per kilowatt hour is equal to fuel consumption in kg per hour divided by brake power is 125. You will get the fuel consumption in kg per hour. Okay. Then what is the fuel injected per cycle per cylinder? There are 6 cylinders, 4 stroke. So if n is the RPM, number of cycles per minute will be n by 2. Why? Because it is a 4-stroke engine. Like that 6 cylinders are there. Therefore, first get the fuel consumption per hour. FC will be 0.2 into 125 kg per hour. That should be equal to the quantity of the fuel, mass of fuel injected per cylinder per cycle into number of cycles per minute into number of cycles per minute into number of cylinders K is 6, okay, n by 2 are there. This is from which mass of fuel per cycle you get. If mass of the fuel is the fuel injected per cycle per cylinder, there will be n by 2 number of cycles are there, and K is the number, K is 6, from which you get the mass of fuel. Kg per cylinder kg per cylinder per cycle, kg per cylinder per cycle. Okay, then divide with because he has asked the with the cc per cycle, no, you will get the answer as 0.0545 cc per cycle. See, there are 6 cylinders. By multiplying the BSFC with the brake power, we will get the how much fuel the engine is consuming in kg per hour. This is the kg. That should be equal to the mass of fuel sent into the each cylinder per cycle into number of cycles kg per hour. No, this is you have to divide this one with the 60. Then you will get the you have to divide this one with the 60. It's because because n by 2 you are writing, therefore we have to divide with this, because you got the kg per hour here. So this kg per minute you have to convert, because there are n by 2 number of cycles per minute are there. then get, and you get the mass of fuel kg per cylinder per cycle, divide with 0.85, you get the, because specific gravity is given, S is given as 0.85, specific gravity, RD, relative density. Density of the fuel is 0.85 grams per cc. Cc or ml, both mean the same. Density of the fuel given. In 63, crank and slot had a quick return mechanism. Okay. Quick return ratio. I am giving the solution here. AB is given as 240 mm, BC is given as 120 mm, (60°). Quick return ratio QRR is equal to 240 by 120. It will be 2. Quick return ratio will be the 2 answer. QRR means quick return ratio. ABCD is a 4-bar chain. Is a question on the 4-bar chain which can be drawn like this. This is the link AB. This is CD. This is 2 radians per second angular velocity of this link. This is 120 RPM. Torque is 50 Newton meter. Four pi radians per second. W out will be 2 radians per second. Mechanical advantage of the mechanism, W in divided omega in divided by omega out, 4 pi by 2, it is 2 pi. 6.28. Answer is B. It is a Oldham coupling. Question on Oldham coupling. Vmax sliding will be d into omega d. Point 3015 meters per second. Answer is C. This is the Oldham question on the Oldham coupling. 66 will be, it is a thrust bearing. It is a friction problem, thrust bearing. Frictional torque 2/3 mu W RO cube minus RA cube divided by RO square minus RA square. You will get the frictional torque. Power lost will be frictional torque into omega 2 pi n by 60. Frictional torque into 2 pi n by 60. It is a thrust bearing. He has given the outer diameter, he has given the inner diameter. Axial load was given. This is the W. Coefficient of friction, this is mu. This is n. And omega is 2 pi n by 60. The power lost will be 26.602 kilowatts. This is a friction torque. Calculated for the thrust bearing, axial thrust bearing. This is the formula. Mu is given, W is given, axial load is W, N is given, coefficient of friction given. It is an axial thrust bearing, the power lost during the axial thrust bearing. 67 is a gear problem, spur gear. 30 number of teeth, N is 200 RPM. mm. R is equal to pi dn by 60. Pitch line velocity. (628.3 mm per second). Module is 2 mm. Module M is 2 mm. Answer is B. N2 by N1 is 1 by 3, T1 by T2 is N2 by N1, that is 1 by 3. T1 by T2 is 1 by 3, T1 will be T1 by 72 is 1 by 3, T1 will be 24. Straight question, simple question. This is regarding the machine gear. V2 by V1 is 1 by 3. Module is 4 mm. Center distance is 200 mm. Center distance is equal to R1 plus R2. Module into T1 plus T2 by 2. Module into T1 plus T2 by 2. T1 plus T2 is equal to 100. You know the ratio that T1 plus 3T1 is 100, implies T1 is equal to 25, T2 is equal to 75. Answer is D. Center distance is given, module is given. Module M is 4 mm. An epicyclic gear train Na is 0. Arm speed Na is equal to 80 rpm. Nb is equal to 140 rpm. Arm speed is 80 rpm. Answer will be 140. A is the answer. '71 question, no answer is matching actually. Given that W is 3 kilonewton, weight is given divided by 9.81 kg, radius of gyration is 1.6 meter, moment of inertia, mass moment of inertia is m square, omega minimum is omega 1, 315 rpm, omega maximum angular velocity is omega 2, 340 rpm. Energy stored will be half I omega maximum square minus omega minimum square. This is the formula. Of course, it is not RPM. They actually have to calculate the omega 1. Omega 1 will be 2 pi into 315 by 60, 2 pi into 340 divided by 60 radians per second. So if we substitute here, we are getting the 70.29 kilojoules, but no answer here. In this question, there is some ambiguity. In the 71 question, no answer is matching. 70.29 kilojoules. The energy stored in the flywheel, this is the formula. A flywheel fitted to a steam engine has a mass, radius of gyration is given, starting torque and may be assumed constant. What is the kinetic energy of the flywheel after 12 seconds? 360 mm, radius of gyration, torque is 580 Newton meter, mass moment of inertia is m square. This is the mass moment of inertia. Torque is equal to I alpha. Alpha is the angular acceleration. 5.594 radius per second square. Omega 2 final angular velocity is initial angular velocity into alpha into time. Omega 1 is 0 initially. Omega 2 is equal to alpha into t. 5.594 into 12. This is 67.129. Final angular velocity is got it. Ke is equal to final kinetic energy is equal to half I omega square. I we already got it, 103 mass moment of inertia, and final final angular velocity is 67.129 square is 233.61 kilojoules. Answer is A. Half I omega square is the rotational kinetic energy. I is the mass moment of inertia given by mk square. Torque is given, tau is equal to I alpha. I is the mass moment of inertia and alpha is the angular acceleration. Rotational kinetic energy is half I omega square for the flywheel. This is a problem on the gyroscope. Mass is 400 kg. Radius of gyration is 0.3 meters. Mass moment of inertia is mk square. 36 kg meter square. Omega is 2400 rpm. Of course, 2 pi n by 60. RPM is 2400. 251.32 radians per second. Velocity is 200 km per hour, kilometers per hour. 200 into 5 by 18 meters per second. Radius is 50 meter. V by R, angular velocity is 200 into 5 by 18 divided by 50, 1.11 radians per second. Gyroscopic couple G is high omega P. 36 into 251.32 into 1.11, 10.04 kilonewton meter. Answer is A. This is a gyroscopic couple. In fact, questions were given numerical questions were given in the theory of machines, particularly gears and gyroscope and the mechanism, 4-bar mechanism is given the more numericals in the theory of machines. What is the vertical height of a watt governor when it rotates? N is 60 rpm. Height is 895 by n square, that is 0.248 meters. Answer is D. Watt governor. Degrees of freedom for a globular spherical pair is 3. D is the answer. Specific speed, actually specific speed of the hydraulic turbine, n root P by h to the power of 5 by 4. Power you can keep it in kilowatts. Direct question on the formula there, it is 202 rpm. This is the head, this is head, this is power, n is given, n is 150 rpm. This is a 202 rpm, mostly it is a Francis turbine. This mostly by saying this, it may be the Francis. This is the range for the specific speed, n root P by h to the power of 4. How do you define the specific speed of the hydraulic turbine? The power developed by the identically homologous series in series of one working under a head of 1 meter. Okay. It is the speed of the geometrically similar turbine of such is that it produces a power of 1 kilowatt when working under a head of 1 meter. Specific speed of a hydraulic turbine is defined as the Speed of the geometrically similar turbine of such a size that it produces a power of 1 kilowatt when working under a head of 1 meter. This is a range. Specific speed is highest for the couplon, lowest for the Pelton wheel, medium for the Francis. It should be a Francis turbine. Unit specific speed, actually speed of a turbine when working under the unit head. It is not the unit specific speed, it should be the unit speed. Unit speed is equal to n by root h. So this is a wrong statement. It should not be given specific. Unit discharge passing through turbine working under, this is correct. Unit discharge is Q by root h. Unit power is power developed when working under not of unit speed, it is the unit head. So this is also a wrong statement. Only 2 is the correct statement. 77 2 only. Only this is correct. Unit power formula is power divided by h to the power of 3 by 2. Unit head should be given, not the unit speed. 77 2 only. Hydraulic turbines he has given good number. Main characteristic curves are the constant head, not the speed. It should be given as the constant head and a constant obtained by maintaining a constant speed. Operating this should be, so this is wrong. This is wrong. Constant efficiency curve are always the Mostill curves. Only 3 is correct. Only 3 correct. Operating characteristic curves are maintained as a constant speed and the main characteristic curves are maintained a constant head. These two are wrong statements. Operating character are obtained by maintaining a constant speed. Main characteristic curves are obtained by maintaining a constant head and a constant gate opening. When you are in drawing the main characteristic curves, speed will be varied and the load will be varied and speed will be varied and speed will be measured. Okay. Centrifugal pump. This is not called as a runner, rather it is called as a impeller. This is wrong statement. Centrifugal pump, no, it looks like this. This is called as the runner. This is called as the volute casing. Okay, this is called as the area of flow increases gradually. This is called as this is called impeller. This is called as the eye of the impeller in the centrifugal pump. In vortex casing, a vortex chamber is introduced. In a vortex chamber, what happens is a perforated chamber will be a perforated chamber, a whirlpool chamber also, a perforated chamber to reduce the eddies. To reduce the eddies, a perforated chamber to minimize the losses, to effectively convert the kinetic energy into the pressure energy. This chamber is called as the vortex chamber or whirlpool chamber. Vortex chamber, other name is whirlpool chamber. This is correct. Foot valve is fitted at the, here the foot valve is fitted. This is the foot valve, strainer, all will be there here. This is also correct. 2, 3, 4 correct. Not the runner. Runner is the word used for the hydraulic turbine. The rotating element of the hydraulic turbine is called as a runner. Here it is called impeller. So first statement is wrong. Runner is the word used for the Francis turbine, Kaplan turbine, like that, Pelton wheel. Rotor is the word used for the steam turbines. The rotating element of the steam turbine is called as a rotor, gas turbines. The rotating element of the hydraulic turbine is called as a runner. The rotating element of a pump is called as the impeller. Centrifugal compressor also impeller. Not only pump, centrifugal compressors also. Volute casing gradually increasing. And if you keep the vortex chamber, there will be efficient conversion of the kinetic energy into the pressure energy. After all, we require, what is the purpose of this volute casing? Kinetic energy to pressure energy. So that can be effectively done if you keep this extra chamber, which is called as the vortex chamber or whirlpool chamber. Both mean the same, whirlpool chamber. What kind of the flow you see here in this in this volute casing, free vortex flow. The motion of the water in this volute chamber will be free vortex motion. This is the impeller, rotating element of the centrifugal pump is called as the impeller. Only 2, 3, 4 are correct. The horizontal distance between the center line of the pump and the water surface to which the water is delivered is called as the, not the horizontal distance, it should be the vertical distance. So first statement is wrong. Sum of suction head at delivery head is called as a static head. Manometric head is the head against which the centrifugal pump is. This is a manometric head. So correct. Head against which is pump is working. 2 and 3 are correct. Answer is B. See, this is the static head up to here. This is the delivery head. Delivery head from the axis to the delivery. Total static head is the HS plus HD. Manometric head will be more than the total static head. HM is always greater than the HS plus HD. The difference being the losses occurring, frictional losses occurring in the suction pipe and the delivery pipe. Ratio of the manometric head to the, manometric efficiency will be GHM divided by VW to U2. That is correct. Ratio of the power available to the power at the shaft of the centrifugal is not overall efficiency, it is the mechanical efficiency. It will take into account the frictional losses in the shaft at the impeller to the power at the shaft of the centrifugal. Power available to the power at the impeller to the power at the shaft. That means between the motor and the impeller there will be some frictional losses, that is accounted by mechanical efficiency. 1 is correct, 2 is wrong. Ratio of the power output of the pump to the power input of the pump is known as overall efficiency. This is overall efficiency. So this is also wrong. Only 1 is correct. Manometric efficiency correct. The other 2 is it should be overall efficiency, not the mechanical efficiency. Outlet velocity. See, centrifugal pump or outlet velocity of flow, yield given. This is the VW2, this is the VF2, this is the what is V2. Square root of VF2 square plus VW2 square. This is a yield component. How much given? This is 5. This is 12. Square root of 5 square plus 12 square. That is answer 13. This is the absolute velocity at exit. Absolute velocity has got 2 components. One is flow component, the other is yield component. This is the yield component given as 12, this is given as flow component. In the here also written, no? This is called yield component at exit. This is the blade velocity. U2 is the blade velocity at exit. Blade velocity at exit. Nozzle efficiency, actual enthalpy drop between the same pressures, correct? Nozzle efficiency, this is the actual enthalpy, this is an isoentropic enthalpy drop, this is the actual enthalpy drop. Correct? Between the same pressure lines. Velocity coefficient as the ratio of the actual exit velocity to the exit velocity when the flow is, yes, that is also correct. Velocity coefficient 1 and 2 correct. Velocity coefficient is the square root of the nozzle efficiency. See, exit velocity, if you neglect the inlet velocity, 2 into delta H isoentropic into nozzle efficiency, right? Of course, into 10 cube to convert kilojoules into joules. This is the exit velocity, actual, and this is the nozzle efficiency. Velocity coefficient is the square of the nozzle efficiency is given. Okay, what is the velocity coefficient? Actual velocity coefficient is the velocity isoentropic if you take velocity if the isoentropic if you take square root of the 2 into delta H iso into 10 cube, right? This divided by this is the velocity coefficient. If you divide that one and take the root, the 3 is also correct. 1, 2 and 3, all 3 are correct. If you just this ratio, no, velocity coefficient, this is the actual, this is the isoentropic. Take the division, you will get the root of eta nozzle efficiency. Square that, you will get the velocity coefficient. All the 3 are correct. Blade efficiency, blade per second, yes, this is correct. Internal efficiency is the ratio of the heat converted to useful total adiabatic drop. Internal efficiency will take into account the frictional losses that are occurring in the turbine. Net efficiency is the rate of brake thermal efficiency to the diagram. This is not correct. 1 and 2 correct only. Only 1 and 2. Internal efficiency will take into account the frictional losses that are occurring inside the turbine. Total adiabatic heat drop. Okay. Blade efficiency, how much work turbine blades are doing, how much energy you are supplying to the, this has got another name in the steam turbines, diagram efficiency. For the DeLaval turbine, we define, right, DeLaval and Parsons turbine. It is another name is diagram efficiency, ratio of the work done on the blade per second to the energy supplied by the steam at the inlet to the moving blade. That is the blade efficiency or diagram efficiency. Internal efficiency is the ratio of the heat converted to the useful work, ratio of the heat converted into useful work to the total adiabatic drop. So that is correct. This will take into account the frictional losses that are occurring inside the turbine. Only 1 and 2 are correct. Bleeding is the process of draining from the turbine and during its expansion. Yes, correct. There is a usual practice to allow the blade steam to mix with the preheated air. That is wrong. Steam will never be mixed with the preheated air. In fact, we never want the air to be there inside the circulatory system of the steam in the steam turbine, because if air is there, air has got a very bad conductor of heat. Particularly in the condenser, we should avoid the presence of the air. If air is there, heat transfer coefficient drastically decrease. So as such, the steam will not condense properly. So the presence of the air in the condenser and anywhere in the system for that matter must be discouraged. We have to take out the air by using the Edwards air extraction pumps or etc. There are some that is called as a deaeration process. Removal of the non-condensable gases from the condenser is called as the deaeration. We do the deaeration very often, otherwise your condenser vacuum will get reduced and the turbine work output also will get reduced. So this is not, it is instead of preheated, if he has given the steam, that is correct. So here it is wrong. To keep the turbine speed fairly constant, yes, this is also correct. 1 and 3 correct. 2 is wrong. We never mix the steam with the preheated air. Actually bleeding is this. Bleeding means what? Steam is, while the steam is expanding in the turbine, the steam is taken, some part of the steam is taken and mixed with the feed water. This is called as the bleeding. This is boiler pressure, this is condenser pressure. Some steam is bled from the turbine and mixed with the feed water in a regenerator. What for that regeneration is done? To improve the efficiency. Any regeneration in any steam turbine will improve the efficiency. It is not the preheated air. If it is given steam, then the answer would have been correct. He has given a preheated air. This is wrong. that indicated power is given, work is 250 divided by 60 kilowatts. Indicated work is given, just to convert into the second, divide with 60, you will get the answer. Thermal efficiency is the ratio of heat supplied. Work output in the isentropic compression to the ideal work, not work output actually, work input there, isentropic compression to the ideal. This is the compression process in the gas turbine. This is the ideal work. This is the actual work. Actual work is more than the this is isentropic. While doing the compression, this is P1, this is P2, P2 is greater than P1. Isentropic work is lesser, actual work is more. Ratio of the work output is given. Isentropic, because what is the meaning of the output there? We have to give the input, no? Turbine is the actual work output. This is correct. 1 and 3 are correct. Actual work input, there is. This is the isentropic work input. Isentropic work input is lesser, actual work input is more. Okay. This ratio, isentropic efficiency of the compressor will be isentropic work input of the compressor is defined like this. Isentropic work input divided by actual work input. This usually it will be around 85%, 80 to 85%. Isentropic efficiency of the compressor. 1 and 3 only correct are statements. 88 question, it is again SM question. A ductile which has relatively large tensile strain. Yes, mild steel, it will get elongated, it won't break, but it will get elongated, lot of strains, longitudinal strains will suffer, but without fracture. Mild steel is the best example, but is a ductile material. Brittle has relatively small tensile before fracture, easily fractures. So cast iron is a brittle there. This is also correct, this is also correct. A static load is defined as which is gradually applied to a mechanical component which changes its magnitude. No, it won't change its magnitude. A gradually applied load, so it won't change its magnitude or direction. This is wrong statement. So 1 and 2 only correct. Brittle material, it undergoes a little tensile strain before. Glass, a simple thing. Glass is a highly brittle, just breaks, right? Mild steel is highly ductile. It gets elongated, longer, thinner, and finally it fractures. 89 question. This is the exercise. Maximum principal stress theory gives a good predictions of. Yes, this is also called as the Rankine theory. Rankine theory, it's meant for the brittle materials. This is a correct. Maximum shear stress theory, yield strength in the shear stress is equal to the yield strength in the tension, half actually. This, it is not equal, rather half. This is wrong. Is known as the Coulomb's or Tescos or Guest theory. See, theories of failure, whether it is a gate examination or the ES, just 5 theories of failure. If you spend around 4 or 5 hours thoroughly on the theories of failure, most of the questions will be asked. Particularly that is useful in the design also. Maximum principal stress theory, maximum principal strain theory, where it is applied. See this. Names also very much important. Answer is 1 and 3. Correct. Again series, it is known as the regarding maximum distortion energy theory. This is known as the von Mises. Very much correct. This is also correct, second statement. Distortion is better agreement in the predicting of a brittle component. Actually, that is wrong. It should be, this is wrong. Not for the brittle, rather for the ductile. 1 and 2 are correct. This is not a brittle, rather it should be a for the ductile material regarding the distortion energy theory. Von Mises theory. Any fatigue failure when the number of stress cycles is called as a low cycle fatigue. This is correct. It is a high cycle fatigue. Highs involves a plastic yielding at its comp. This is wrong. Only 1 and 2 are correct. The design, this is a design part. In the bolted joint is an example for the permanent joint. No, nut and bolt it is a temporary. Quarter joint is an example of separable joint. In hand riveting, this is also correct. Shank and blows are applied by a hammer, and the hand riveting. Some questions are straight, and just by reading the question also you would be getting some idea how to answer that. Bolted joint cannot be an example of permanent joint. Nut and bolt we always open and close, right? So 2 and 3 only correct. '93. Counter shaft is or jock shaft is a secondary shaft. This is correct. Jock shaft is also other name of the counter shaft. This is also correct. Which are connected axial direction by means of the couplings. So this is wrong. So 1 and 3 only correct. In the design, machine design is asking mostly about the types of the shafts. Machine shaft, counter shaft, jock shaft. So varieties of types of the shafts is asking. The 1 and 3 are correct. '94 question. T1 is 20, T2 is 120, module is 4 mm. This is again a theory of machines. Center distance is R1 plus R2, that is given by module into T1 plus T2 by 2, that is 4 into 20 plus 120 by 2, that will be 280 mm. Answer is B. This is again the regarding the gears. 95. Expected life will be, here answer is C. L90 will be 8000 into 60 into 1450. 696 million revolutions. 96 will be, zero film is a bearing which operates without any, this is correct, no lubrication. Thin film lubrication describes where the two surfaces in the relative motion are completely separated. No, they are partially in contact. Hydrodynamic lubrication, in which the load supporting fluid film is created by shape and relative motion. This is also correct. 1 and 3. This is the hydrodynamic bearings. Regarding the hydrodynamic bearings, he has asked. In the 97 question, molybdenum disulfide is a semi-solid lubricant. It is not a semi-solid lubricant. It is used to protect bearing from corrosion. Any lubricant is meant for reducing the wear and tear, protect the bearing from the corrosion. That is a basic purposes of any lubricant used in the hydrodynamic bearings. The energy absorbed by the brake. A flywheel is rotating, it is brought to rest. How much energy is absorbed by the brake? Half I omega square. Energy absorbed, all that rotational kinetic energy of flywheel, all of that will get absorbed. Half into I is equal to mk square into omega. Omega is, the omega is directly given. 94.9 kilojoules. A flywheel is rotating, right? A brake is applied, and that comes to halt. All that rotational kinetic energy will get converted into the heat, and that will be absorbed by the brake or the brake oil. 99 is B. 1 and 3. See, function of the stores and releases energy, that is a function of the flywheel. Why the 4-stroke engine requires a bigger flywheel than the 2-stroke engine? Because there is a more variation of the turning moment, variation in the cycle. Okay. And it won't increase the power capacity, it reduces the amplitude of the speed fluctuations. Flywheel is meant for the reducing the changes in the speed during a one particular cycle of operation. The governor and flywheel both the same, but the governor maintains the constant speed of the prime mover whenever the load is changing for a finite period of time, whereas this is during one cycle of operation. Flywheel, the main difference between the flywheel and the governor is flywheel takes care of the speed variation during a one cycle of operation by reducing the turning moment variation. By reducing the turning moment variation, it maintains the constant speed of the shaft. 1 and 3 only correct. 100 is governor control by varying the fuel supply, that is correct. Flywheel has no influence on the mean speed, that is correct. Flywheel may be used, actually flywheel we don't require to be used when the fluctuations of the output are negligible. Only 1 and 2 are correct. This is again regarding the power plant. Utilization factor. What is utilization factor? Utilization factor is defined as maximum demand on power station, divided by rated capacity of power station or the power plant. What is the rated capacity? See that rated capacity, one generating unit is 250 plus 2, that will be 550 megawatts. But it is a maximum demand for the power station will be, maximum demand is 350, because see that straight line from 350 to 80. So maximum demand is 350, rated capacity is 550, that is 0.636. Utilization factor is maximum demand on the power station divided by the rated capacity. Power is supplied with one generating unit of 250 megawatt capacity and 2 units of 150. Rated capacity is 550. Actually this question, he is asking the higher calorific value. What is this higher calorific value? Generally any fuel comprises carbon, hydrogen, sulfur as the main combustible constituents. Any fuel, solid fuel or liquid fuel or a gaseous fuel, any fuel, petrol or a diesel or a kerosene or a coal, any fuel contains combustible constituents as carbon, hydrogen, sulfur. Okay, C combines with oxygen to give the carbon dioxide. If it is undergoes complete combustion, 2H2 plus O2 is 2H2O. Sulfur S plus O2 is SO2. All of them are highly exothermic. Lot of heat will be evolved. Okay, heat released. But this water vapor, supposing if the combustion gases are cooled down to the room temperature, that water vapor formed because of the combustion of the hydrogen, this is water vapor. Plus Q I am writing. Plus Q means heat. All are exothermic, The heat liberated. Calorific value means what? Heat liberated when 1 kg of the fuel is completely burnt. That is called calorific value, general definition. Why it is called a higher calorific value? whatever the H2O, water vapor is there, when it is cooled, it becomes liquid. So when the water vapor is coming to a liquid, it liberates latent heat of condensation. So that heat is also accounted in calculating the higher calorific value. Higher calorific value is defined as the amount of heat liberated after burning 1 kg of the fuel completely, that too after cooling the combustion products down to the room temperature. When you are cooling the combustion products down to the room temperature, the water vapor present in the combustion gases will condense. When it condenses into the liquid, it liberates latent heat of condensation. So that also comes into picture while you are calculating higher calorific value. Supposing if you don't cool the combustion gases down to the room temperature, if you just evaluate how much heat is liberated by burning the 1 kg of fuel, if you just evaluate, that is called as the lower calorific value. HCV minus LCV is the latent heat of condensation liberated due to condensation of water vapor formed by combustion of hydrogen. If hydrogen is not there in the fuel, there is no difference between the HCV and LCV. If the fuel does not have hydrogen, then no difference between HCV and LCV, because there is no water vapor being formed. All the makes the difference is latent heat of condensation liberated due to condensation of water vapor formed by combustion of hydrogen. So in fact in the problem here the formula also, this C is forgotten. Actually the question itself is wrong actually. In the HCV you should have given the C here, percentage of the carbon. See that, percentage of the carbon. Okay. Solid HO, sulfur is given, but there must be a carbon there, right? Solid fuels. So you did not mention the carbon percent. This is S for sulfur, H for hydrogen, O for oxygen. There must be C should be there. So then the answer will be option C. C for carbon percentage. That is not given. It should have been given that. That is called Dulong-Petit formula. Simply is called Dulong formula. Answer is C. Okay. In reaction turbine, steam expands in the stationary nozzles and attains high velocity. The nozzles are there in the impulse turbine only. Impulse turbine steam enters the fast moving blade and rotor. If the steam is superheated, diagram may be increased. If the steam is superheated, definitely when the Rankine cycle, if the steam temperature is increased, supply steam, you get the more efficiency. That is correct. The resulting high velocity impinges again, which alter the direction of the steam jet changes. This is also correct. Does not increase with increase in years of service. Actually 3 and 4, 2 and 3 only correct. 1 is wrong, 4 is wrong, 2 and 3 only correct. See, what the impulse turbine example is Delaval turbine. Okay, in the Delaval turbine, the moving blades or steam is impinging onto the blades. Because of the change in momentum of the steam, there is an impulsive force. That what happens in the Delaval steam turbine. Because momentum of the jet is changed, causing as the impulsive force. That is what happens in the Delaval turbine. 2 and 3 are correct. Now there is steam will be coming from the fixed nozzles, high velocity steam nozzles will be there. Actually in the reaction turbine also, actually more correctly, the question is not correctly given. The reaction turbine also there will be nozzles, but there it is called fixed blades. There will be a partial expansion of the steam happens. What happens in the Parsons turbine, reaction turbine example is what? Parson. Steam expands partially in the nozzles, partially in the moving blades. That is why degree of reaction is 0.5, 50%. 50% expansion happens in the nozzles, 50% expansion happens in the moving blades, in the reaction turbines called Parsons turbine. In the pure impulse turbine, entire expansion happens only in the nozzles only, stationary nozzles only. But if the superheated steam is increased, temperature is increased, you get more and more expansion, more work output and more efficiency. Rankine cycle efficiency may be increased by increasing the superheat temperature, because the mean temperature of heat addition will increase. By increasing the superheat temperature, mean temperature of heat addition can be increased. That was question was asked in the gate also. Gate 24 also the same question was asked. Overall efficiency, load factor, this is a question on the load factor. Load factor is equal to average load divided by peak load during a certain period of time. Okay, load factor is given 0.5, average load divided by peak load is 40, therefore average load will be 20 megawatt and 20 megawatt, right? So how many kilowatts? 20 into 10 cube kilowatt in a day. Per day how many hours, you know? That is energy produced per day will be, per day is asking, energy produced will be per day, because in a day there are 24 hours, kilowatt hour. Answer will be 24 into 2, 48. Answer will be B. Average load factor is defined as average load by peak load during the certain period of time. Okay, that is, this is the peak load. An increase in the initial pressure of steam, that is a very commonly asked question in the Rankine cycle. If you increase the boiler pressure, definitely your thermal efficiency will increase. Thermal efficiency will be rising the initial time without changing the pressure, will be dropped. Wrong, it will increase. If you increase the rising initial temperature there, if you increase more and more, if your efficiency will increase, because the main temperature of heat addition will increase. Intermediate reheating of improves the thermal efficiency. That is a correct, but not always. But that is not always. So if the reheat pressure is very, very low, then efficiency may be decreasing also. Reheating of the steam in a Rankine cycle may not guarantee increase of efficiency all the time. If it is too low, reheating of the steam is happening at very, very low pressures, much lesser than the boiler pressure, then reheating may result in decrease of efficiency also. But we don't consider that effect. We may think that generally reheating will result in the improvement of efficiency. An increase in the initial pressure improves the thermal efficiency of steam power plant and also the wetness fraction of the steam. Wetness fraction of such steam decrease. Actually, wetness fraction, there is a very dryness fraction. More correctly, it should be acted as a dryness fraction of the steam decreases. Yes. If you just look at this point I have discussed earlier also. If the boiler pressure is increased, the dryness fraction of the steam will decrease. Definitely you will improve, it will improve the efficiency, but there is a danger of the turbine blade erosion. See, this point is moving to this point. The remedy is reheating. That is why we provide the reheating. The main purpose of providing reheating is this danger can be avoided, particularly when you are using the higher boiler pressures. Definitely if you provide the more boiler pressures, you will get more efficiency, but simultaneously there is one danger called as a turbine blade erosion. That danger can be avoided. What is the remedy for that? By providing the reheating. So decreases the, and also dryness fraction of decreases at the end of the steam. So 4 is also correct. One I can say more correctly, this is some ambiguity in the question. 1, 3 and 4 is actually if you see wetness fraction, if we don't take it as a dryness fraction, If we just take it as the wetness, wetness decreases. It won't decrease, wetness will increase actually. See, if you see, he has given the wetness fraction. There is no word called wetness fraction in our power plant engineering. There is a word called dryness fraction. If you think the opposite way, wetness fraction opposite to that of the, then 4 will be a wrong. 4 will be wrong, and 1 and 3 will be correct. D will be the answer. If you think that the wetness fraction is opposite to that of the dryness fraction, it will decrease. Okay, wetness fraction will decrease. Wetness fraction of such steam decreases. At the end of the, actually if you just think that, that question is somewhat very vaguely being asked there. Okay. If you think that wetness is something like a, wetness will increase, right? Wetness will increase, it will not decrease that. Dryness fraction will decrease, so then this will be a wrong statement. Wetness fraction will decrease, so answer will be 1 and 3. But finally if you think that as you are providing more boiler pressures, the point during after the expansion is moving leftwards, the quality or the dryness fraction of the steam is decreasing. So you are going into the wet region. Answer seems to be more correct with 1 and 3. In a natural draught cooling tower, what is a cooling tower? The steam, the water coming from the condenser drops, and from the below you will be blowing the air. If you are putting the fans here, then it is called forced draught. Fall over the load. Cold water, not the cold water. It should be the hot water. Wrong. In atmosphere, it to the hot water from the pump to the after the nozzle situated near the bottom. Actually, not the nozzles are situated near the top. This is wrong. Forced draught cooling towers, draught fans are installed at the bottom. If you keep here, it is FD. If you keep the fans here, it is called ID. Mechanical draught means you have to keep the fan. Natural draught means you don't keep the fan, only the height of the tower itself will provide the necessary pressure difference for the flow of the air. So if you allow the atmospheric air by using the fans here, this is called as a forced draught. If you keep the fan here, it is called as the ID fan. If you keep both the fans, it is called as a balanced draught. Balanced draught. FD fan here, ID fan there, balanced draught or hybrid draught they call. Okay, mechanical draught means we will always keep one fan there. So see like that, draught fans are installed at the bottom. This is FD fan, this is a ID fan. Okay. ID means it will draw the air from the water will be hot water will be pouring down, and you will blow the atmospheric air. Okay. Answer is 3 and 4. C. There in the cooling tower, water coming from the hot water coming from the condensers, cooling water will pick up the heat from the steam. It becomes heated and goes to the top of the tower and sprinkled here. Water will be sprinkled, and you will be by using these fans you will be blowing the atmospheric air. The upgoing air and downpouring hot water will directly come into contact. It is a direct contact type counterflow heat exchanger. Downpouring water and upgoing air will be directly coming into contact and exchanging heat. So it is a direct contact type counterflow heat exchanger, where there will be heat transfer and mass transfer between the water and the air. So if you keep the fan here, it is FD. If you keep the fan there, it is a ID. If you keep both, it is hybrid, but finally it is called mechanical draught. If you don't keep any fans, it is called as a natural draught. But in all the cases, hot water from condenser will be sprayed by using the nozzles, and which will be transferring heat to the air, and water will fall down. Cold water, then cold water will go to the condenser to pick up the heat from the steam. So cooling tower is the most essential component. Whenever there is no whenever there is no river or there is no pond, so resource of water, definitely we have to depend on the cooling tower. Cooling tower, after cooling the water will go to the condenser, picks up the steam, picks up the heat from the steam and becomes hotter. That comes to the tower, gets cooled here. That is how the circulation maintains. So the power plant turbine exhaust, power plant, see how many questions he has asked, at least 15 questions he has asked. Power plant, in every IAS question paper, power plant dominates. As the turbine exhaust pressure drops, power plant cycle improves. As the boiler pressure increases or condenser pressure decreases. Use of condenser decreases the, this is correct, decreases the size of the boiler installation. If you don't use the condenser you may need to spend more, you have to generate more steam in the boiler. Supposing if you are condenser, without condenser, if you are operating the system, you can't get much work output from the turbine. Okay, you can't get. If you use the condenser, you are getting more work. Therefore, the steam to be recirculated in the system will get reduced. That is also correct. Governed by the inlet water temperature, yes. How do you get the vacuum in the condenser? In the condenser, which is a shell and tube heat exchanger, you get the vacuum because when the steam is coming, the change in specific volume of the steam. When the steam is condensing into the liquid, because you are circulating the cooling water, and when the steam is condensing, it becomes water. So it falls into the hot well. This is a hot well. So when the steam is changing its specific volume, a lot of specific change in specific volume, there is a vacuum created, huge vacuum, 65 centimeters of Hg vacuum we get usually, 65 centimeters of Hg vacuum. Pressure inside the condenser is far less than the outside atmosphere. So how much vacuum you get depends upon the cooling water inlet temperature, because if you are supplying the very low temperature cooling water, lot of heat transfer could happen and steam can condense very rapidly, you may get more vacuum. Supposing if the inlet temperature of the water is more, if there is no proper heat transfer between the steam and the cooling water, steam will not condense properly. When the steam does not condense properly, we don't get much vacuum. So how much vacuum we are getting? It is mainly dependent upon the rate of heat transfer between the steam and the cooling water. That rate of heat transfer between the steam and the cooling water is more if the cooling water temperature is low. So that is also correct. All the statements are correct. Okay, understand? The temperature of the cooling water inlet temperature decides the rate of heat transfer. That in turn decides the how much vacuum you are able to get. Vacuum means the pressure much less than the atmosphere. So how much vacuum are likely to get depends upon the cooling rate of heat transfer, which in turn depends upon the inlet temperature, again which in turn depends upon the WBT of the atmospheric air, because after all this water is coming from the cooling tower. So the wet bulb temperature of the atmospheric air decides this cooling water inlet temperature. So all are interlinked. Okay. Multi-cylinder which have their rotors mounted on one end of the same shaft coupled to it is a single shaft turbines. Consider the following features for a gas turbine power plant. Intercooling increases the work output, regeneration increases the efficiency, reheat increases the work output. All three are correct. Specific output and thermal efficiency. Regeneration improves the thermal efficiency. Intercooling improves the network. Reheating improves the network. So all the three. Carbon combines with oxygen to give carbon monoxide. It may give carbon dioxide or it may give carbon monoxide, correct. 2H2 plus O2 is a 2H2O. Water vapor, not water, water vapor, more correctly water vapor as the product. With methane burns in the presence of oxygen, CH4 plus oxygen, CO2 plus 2H2O. Okay. So this is the formula. So another answer is all the three are correct. But actually it should be water vapor, not the water. So answer is 1, 2, 3. This is water vapor. Air contains 21% and 79% by volume. This is wrong. This is wrong statement. This is correct for the mass. 23% of oxygen and 77% of nitrogen by mass. Okay, if it is mass, then it will be correct. If this is mass, then it would have been correct. Natural gas, and this is correct. Cool gas, this is correct. 2 and 3. If one statement you are finding wrong, directly you can go to the options. The questions are framed like that. You should have low ash content and high calorific value, good coal, that is by lignite, bituminous coal, anthracite. Anthracite has got the highest percentage of carbon and low ash content. It should have the not large percentage, wrong. If sulfur is there, it will form sulfur dioxide, SO2 plus H2O, if water vapor combines, this is H2SO4, highly corrosive. Combustion equipment will get spoiled because of this sulfur. You should not have the sulfur. You should have high grindability, that is correct. So 1 and 3 are correct. 1 and 3 are correct. $113, it is a managerial role performance. It is a manager should be able to interpersonal. You should play the leader role. It is the quantitative approach. Statistics, models, that. Regarding the purpose of micromotion study, all the 3 statements are correct. Most efficient way of accomplishing the elements, 1, 2, 3. D is the answer. 116, computer aided manufacturing, it is 3 only. Monitoring the progress is a computer aided manufacturing sim, shop floor only this is correct. This is wrong, this is wrong. It is the welding workspace, is not included in the flexible manufacturing systems. Answer is D. The project manager has full authority over the project. Team members report to one boss. This 3 is wrong. 1 and 2 only correct. Direct cost increase with time, wrong. This is 2 and 3 are correct. Redundancy, regarding warm redundancy. In fact, this is correct statement. Actually, there is some vague vague answer is there. Only 3 only is supposed to be the answer. Passive redundancy is known as standby redundancy. That is correct. This is regarding the manufacturing. Strip casting. Thin slabs are produced by using the strip casting. This is regarding the forging. All 3 statements are correct. All 3 statements are correct. This is also the only question asked regarding the farming or the forging. It is the measuring the thickness and inside dimensions. It is a micrometer. Of course, sine bar is for the taper angle. This is for the taper angle. This is for the flat surface plates. This is used. Anvil is a different application. Only possible answer is micrometer. It's the very easiest question regarding the metrology. Okay. The technique that creates a 3-dimensional image by using an optical system is a holography. It is a holography. It is a metrology and inspection. Dimensional image of the 3-dimensional image of the part by utilizing the optical system is called holography. Welding flame with excess oxygen is an oxidizing flame. Welding only 1 or 2 questions. All these questions have come regarding the solar, this thing. All these are renewable there, renewable energy. Sun radiates energy uniformly in all directions in the form. Yes, sun is a black body. That is correct. the output of the sun is 3.8 into 10 power 26 watt. This is the total energy emitted by the sun, out of which 1.7 into 10 power, out of which this is strikes 1.7 into 10 power 17 watts strikes earth. This is the energy striking the earth. Okay, so only one seems to be correct, 2 is wrong and 3 is also wrong actually, but kilowatt per hour is it. This is the kilowatt because you have to calculate this one, strikes joules per second, per hour how much striking, and multiply with how many hours are there in an year. Maybe this is wrong, 1 and 3 are correct actually, but we have to calculate 3.8 into 10 power 26 watts is output, solar output. Sun emits this much energy, out of which this much energy strikes the earth, but it is given in watts. Here the units given in kilowatt hour per hour. So multiply with how many hours are there in an year and calculate that, multiply with this, maybe you are getting this answer. Solar radiation, pyranometer measures, cannot, it can measure, so it is wrong statement. Generally solar radiation, when the energy emitted from the sun, if this is the earth, the energy directly striking, it is called as the beam radiation or direct radiation, and most of that energy will be reflected and absorbed by the immediate gases present in the air, because in the atmosphere there are oxygen, nitrogen, dust, water particles, smoke, water vapor, so many are there. They all scatter the solar radiation. So energy that is coming from all the directions, it is called as the diffuse radiation. This is the direct or beam radiation, direct or beam radiation. This is the earth, this is the sun. So the total radiation is the sum of diffuse radiation and direct beam radiation. Diffuse radiation means energy coming from all the directions due to the scattering, of energy or attenuation, that is also called attenuation. So this is a correct, this is sunshine recorder measures the sunshine hours in a day. It all depends upon the location, latitude, etc. Okay, location, because if you go to the Antarctica, the sunshine hours will be very, very small. So than the places near the equator, it will be more. 2 and 3 are correct. Pyranometer measures the diffuse radiation. Diffuse radiation means the energy after getting scattered coming on all the directions and falling on the earth. Sum of beam is called as the global radiation, correct. Diffuse radiation does not have a unique direction, correct. Received at the end without change of direction is called as a direct or beam radiation. 1, 2, 3, all 3 are correct. The sum of beam and diffuse radiation referred as total global radiation as the total radiation. All these questions regarding the renewable energy, solar energies. Nitrogen absorbs X-rays and extreme. In fact, out of the total solar radiation, the stratosphere, there is one layer called as the ozone layer. That prevents the ultraviolet radiation. Cannot absorb is asking. So it is a wrong statement. It absorbs the UV radiation. Ozone layer is the main protecting layer present in the stratosphere, absorbing UV radiation. That UV radiation is highly dangerous to our human beings because it causes the skin cancer. The domestic refrigerants, earlier refrigerants, they are spoiling the ozone layer. That is why most of the refrigerants are being banned, and new refrigerants which do not damage the ozone layer, they are being produced. Any refrigerant having chlorine atom will damage the ozone layer like anything. Ozone depleting parameter they call. So ozone must be protecting the earth from the UV radiation. 2 is correct. Dust particles and absorb a part of radiation irrespective of wavelength. Dust particles, air molecules. Air molecule means nitrogen, oxygen, They absorb some energy, they scatter some energy. But UV radiation is absorbed by ozone layer. So 1 and 2 are correct. Extraterrestrial radiation. Extraterrestrial radiation, that is correct. Solar radiation, that is after passing through the earth, it is known as the terrestrial radiation, that is correct. Solar insolation is defined as the given surface area and given time. Insolation means how much energy is falling upon the surface after reaching the earth. All the three are correct. Solar radiation incident on the outer atmosphere of the earth is called as the extraterrestrial radiation. This is the terrestrial, means what is falling upon the earth is called terrestrial radiation. Passing through that atmosphere that reaches the earth's surface is called terrestrial. Collector efficiency is the energy actually absorbed and transferred to the heat transporting, that is correct. Concentration ratio is the ratio of the area of the aperture by area of the receiver. He has given the reverse, that is wrong. This is correct. 1 and 3 are correct. Concentration ratio is the ratio of the area of the aperture divided by area of the receiver. It is given the reciprocal, so that is wrong. The concentration ratio is in the range of parabolic concentration is 3 to 7, may be achieved by cylindrical, that is wrong. Fresnel lens collector with which yields temperature between 150 to 300. 1 and 3 are correct. If natural means adapted to the solar greenhouse, adapted to collect, store and distribute the energy inside is known as the active greenhouse. It is called as a passive. It is not active, rather it is called as the passive. So it is wrong. The 2 and 3 statements are correct. Arid zone means where there is no water is there, and is conserve water resource. Greenhouses or the solar greenhouses, they protect the water. Arid means where there is no water availability. Water availability is scarce. To conserve the water resources, solar greenhouses are designed in the arid zones. 2 and 3 are correct. C is the answer. Here all the 3 statements are correct regarding the wind energy. It is how to extract the wind energy. 135, charcoal is obtained by biomization. It is wrong. Not biomization. Charcoal is obtained by a process called pyrolysis. Gasification, biomass gasification, pyrolysis and hydrothermal carbonization. They are the methods used to get the charcoal. When you have got the woody biomass, by using the pyrolysis process, we convert that woody biomass into the charcoal. This is correct. This is wrong. Raw vegetable upgraded as biodiesel to a chemical process called transit. This is also correct. Nowadays, all the modern diesel vehicles are being run with the biodiesels because the pollution, exhaust pollution also will be quite lesser. Here this is not the maximum, here it is actually minimum. So answer 1 is wrong, 2 and 3 are correct. This is a tidal energy regarding the water tidal. So renewable sources, solar, wind and tidal. He is asking the tidal energy also. This is the basic phosphoric, this is correct, this is correct. It is not a positive, rather it is the negative. That is why this is wrong. 1 and 2 are correct. All 3 are correct. Here it is a robotics and mechatronics. Vision is vision is the most important sensory channel for human. That is very common sense. visual input to support a robot's learning process. This is robotics and mechatronics. There are about 10 questions being asked. All 3 statements are correct. Trajectory is a path with a time constraint. No, with a time constraint. As a different instants of time, where that machine will be. That is a trajectory. Geometric model of the workplace. Collision-free path of the trajectory. Geometric model of how the workplace is oriented. This is a fuzzy output set. Kinematics is the study of motion. No, because these are the things we have learned in at 11th class. Kinematics is the study of motion only regarding the velocity displacement without bothering the force and torques. Dynamics is a study without consideration of the force. We have to consider the force and the torque. F is equal to ma, dynamics, basic dynamics equation. Okay. Here when you are writing here, say v square minus u square is 2as. We are not bothering about the forces and torques. We are just calculating the displacement velocities, where the particle is, where the machine is, okay, where the body is, right. So this is wrong, this is also wrong. Only one is correct. See, some questions we can use the common sense and we can keep like that. That is why this paper is very much typical. Human sensory system 143, all 3 are correct. Kinematic pair, prismatic joint, 2 or more links at their nodes. It is again connected to the theory of machines there. Harrow 1 is a prototype human-like robot. (145) is 1 and 2 only. (146) is tactile sensors. 147 is 2 and 3 only. A robot is a machine which is skilled at executing motions. Okay, that is a general definition of a robot. Control system is called joint space control. Autonomy is a characteristic atomized system of degrees of independence. Independent, no? Autonomy means what? Automatic, no? Atomized systems, degrees of independence. A molecular vision system takes place, input produces geometrical measurement as output. A monocular vision system normally composed of a single electronic camera and image digiter and computing the hardware. Electrical signals picked up by the imaging sensor of the camera will be converted to analog image. The function of the parallel splitter motion is to duplicate the input motion into the multiple output motions. Only A is correct. So, in fact, there are the few questions in the robotics and mechatronics seem to be a bit vague actually, but by reading the question properly, see, the IAS questions are set by UPSC, unpredictable, sir. UPSC is unpredictable. So, some questions are quite unpredictable as such. So, that we can see in the last portion, mechatronics is also right. We cannot guess the questions from which direction the questions are asked. But overall, if you see the paper, majority of the questions as you observe, fuels and combustion, steam power plant, gas turbine power plant, steam nozzles, almost I can finding out of 150, 20 questions they are being asked in that. Power plant in the sense, hydroelectric power plant, steam power plant, gas turbine power plant, all put together. In the fuels and combustion. See, there are many questions, 4 or 5 questions are asked only on the fuels and combustion. Calorific value, what are the combustion things. So, our basic combustion equations, if you know, you can answer the questions. Questions are quite very easy actually. Those combustion equations and how to calculate the what fuel contains what. So overall that power plant domain where you deal with the fuels and combustion, steam power plant, gas turbine power plant and hydropower plant. Hydropower plant means it includes pumps, centrifugal pumps, hydraulic turbines, all that is comprising around 25 to 30 questions I guess out of 150. And heat transfer 7, 8, thermodynamics, actually questions are quite lesser there in thermodynamics. Heat transfer again asked, fluid mechanics about 11 questions, and strength of materials around 13, 14 questions, machine design about 5 to 6 questions, theory of machines around 7 questions you have seen there. So he has distributed all the questions among all the domains, but R&AC IC engines also has asked about each 8 to 9 questions there, IC engines there. Questions are quite easy, very, very easy. If you have a very basic ideas, how to define the basic formula of mean effective pressure, thermal efficiencies, what is the meaning of overall efficiency, indicated thermal efficiency, you can answer most of the questions. I hope that mains paper may not be that much easy, but if you just observe the gate solutions I had given earlier and these IES solutions, there is a lot of difference you are observing. The depth of the question, the type of the question, the IQ what you require to solve the questions are much, much greater in a gate as compared to the IES. But I advise you, those aspirants who are going to write for the gate also, try to solve some questions, not all the renewable is not there in the gate, renewable energy sources, and centrifugal pumps is not there, hydraulic turbines only very little weightage they may ask, but when you come to the gate, the weightage is given more to the fluid mechanics, heat transfer, thermodynamics, theory of machines and about strength of materials usually, but this time strength of materials have asked a little there, only 4 or 5 marks. But here you see he has asked almost 12 to 13, easy paper, all the questions just by read it and keep it like that, very little numericals was asked in this strength of materials here. But what I suggest is, those who are preparing for the gate examination also, try to refer the recent prelims, try to solve. First you finish all the gate paper solutions in the recent years. After finishing that, if you find time, you may refer to the prelims paper also. Generally last I can say the how many marks if you say means around 60, topper may get around 60 to 65%. A topper, IES topper may approach around 65% this year, easier as compared to the last year IES prelims. That is my observation. So I hope you understood the concepts which I had given by me. This is Sekhar from M Sigma Gokulam. Wish you all the best, dear students. Good luck.